Hello everyone, this is Vikram and welcome to my channel. In this video, we are going to talk about Jenkins end-to-end pipelines on Kubernetes. That is, we'll write end-to-end declarative pipeline in Jenkins by integrating tools such as Git, Maven, SonarQube, Nexus Repository Manager, Docker, Kubernetes, Helm, etc. So we're going to see in-depth integration on these tools, how to install these tools on Kubernetes, how to configure them to talk to Jenkins, and how do Jenkins utilize these tools for various CI/CD activities. So without further delay, let's get started. So this is the complete pipeline or the complete flow that we are going to see. But what is so special about this pipeline? You might have seen this in hundreds of YouTube videos and blogs in online. So for starters, we are going to set up everything from scratch, and that too on Kubernetes. So we will not use the older ways like deploying it as a service or running it as a container. We'll see how to run these tools as Kubernetes pods on Kubernetes environment, just like how we do it in production. So not only this, we'll also see how to deploy these tools using Helm charts and utilizing some of the concepts such as cloud load balancers and persistent volume claims. So imagine you getting a task of setting up a complete CI/CD platform in your environment. So after watching this video, so I'm sure that you'll be able to set up everything from scratch, and that too on Kubernetes. And not only setting up these tools, you'll also be able to write some basic to complex pipelines by integrating these tools and creating a complex CI/CD pipeline. And along with this, we'll also see how to configure these tools, how to interface them together, how to use webhooks to connect these tools together, and also how to send email notifications after each and every Jenkins stage, how to use GitHub APIs to send build information to your pull request, and finally we'll also see how to run this pipeline only when you open a PR from one branch to the another branch. So we'll also see how to run this pipeline only when PR is open and not when PR is closed. So there are a lot of integrations, lot of configurations that we are going to do. So let's start everything from scratch by configuring and installing them on the Kubernetes environment. So we already talked about Jenkins agents in our previous video, that is using Kubernetes pods as Jenkins agent. So in case of Jenkins Kubernetes pods as agent, your complete job will run inside a Kubernetes pod. Let's assume you wanted to clone a repository and build it with Maven tool. So how do you do that in case of normal Jenkins? So basically you'll make sure that Git and Maven are installed in that node. So in case of Jenkins Kubernetes pods as Jenkins agent, so we'll take a container image in such a way that that image will be used for that particular stage. So in case if I want to clone a Git repository, what I'll do is I'll choose a container in such a way that I have Git installed in that container. Similarly, if I have to build it using Maven utility, I'll make sure that the container image which I choose has that Maven binary in that container image. So in case of Jenkins agents in the form of Kubernetes pods, we'll create a pod in such a way that its containers will be able to complete your complete CI/CD pipeline. So let's assume I need two different utilities for my pipeline like Git and Maven. So what I'll do is I'll create a pod with these two containers running. So these come to multi-container patterns where a pod can have multiple containers. So in this case, I will have one container with Git install and another container with whatever utility I want to build my source code. So in case if I need Maven utility, I'll choose the container image in such a way that Maven is installed. And if you see along with these two containers, there is one container called JNLP. So this is basically an inbound agent container, and this container is responsible for talking back to your Jenkins master pod. So if Jenkins master has to run a job inside a pod, so what it is going to do is it is going to call the API server in Kubernetes to provision a pod for you. So this pod is like an agent pod in which your complete job will run. So template of this pod will be decided by the user, like how many containers it should have, etc. And here I have two different containers like Git and Node, and Kubernetes will automatically add. So not Kubernetes, so it's basically Jenkins. Jenkins is going to add an extra container so that this container will be able to talk to the master pod over JNLP, that is 50,000 board. And once your job is done, this complete pod will be destroyed, and if you initiate the job again, another new pod will be created and your job will be executed in that particular pod. So complete explanation of this is already covered. So if you want to know more about how Jenkins Kubernetes pods, agents will work, so you can refer our previous video. And these are the various things that you are going to learn. So you're going to understand how to set up local CLIs so that you can talk to various clusters or various tools. You'll learn how to create a Kubernetes cluster on DigitalOcean and how to set up various DevOps tools such as Jenkins, Nexus, SonarQube, email, etc. on Kubernetes. We'll also understand how to use load balancers and persistent volume claims on DigitalOcean cloud, and how to create and use Helm charts to deploy our application. So we're going to refer an open source example I'm going to show you in some time. So we're going to see how to write Kubernetes Helm chart. It's an Helm chart for that application. We'll also see how to write a basic to complex declarative pipeline by connecting all the tools such as Nexus, SonarQube, etc. We'll also understand how to use Kubernetes pod as build agents. We covered this in previous video, but we did not cover any real example. So in this video, we're going to do the same. Like, we are going to take a real example and see how Kubernetes pods will act like build agents in Jenkins. We'll see various stages like cloning a Git repository, building its source code and scanning it for some code quality, and storing all the artifacts of the build process into a repository like your Nexus repository. And the artifacts can be a war file, container image, Helm charts. So we're going to see all these. We'll see how to store a war file, how to store a container image, how to store a Helm chart in various repositories. And finally, once everything is done, in the final stage, we are going to go for the deployment using Helm charts. So we are going to talk to the Kubernetes cluster and deploy our application using Helm charts. And not only this, we'll also understand how to create and use custom quality gates in SonarQube to measure the quality of your application, and then how to trigger a pipeline only on pull requests, and how to update pipeline status to GitHub pull request. So basically, when you open a pull request from maybe dev branch to the master branch, so you will trigger this pipeline, and only when the pipeline is successful, you're going to merge the branches together. And in order to merge the branches together, and in order to know whether your pipeline is successful or failed, so many a times you'll either rely on notifications, or you might go to the Jenkins and see whether the build is success or not. So in this case, what we are going to do is we are going to see how to see that status in your pull request itself. So your Jenkins, once it completes each and every stage, so it sends a notification back to your GitHub saying that particular stage is passed or failed. So now if you see, I have various stages, and the status of these stages are getting displayed in my GitHub pull request. So basically, this is done by your Jenkins. So Jenkins will send whether that particular stage is passed or failed, and now GitHub can display that status in the PR. So using GitHub APIs, we are going to see, and you can see here one of the stage failed, that is the deployment stage. So once this is failed, so you can also see the merge request button. Instead of green, it is appearing as gray. It doesn't mean that you cannot merge it. You can still merge, but here Jenkins is displaying some information whether the stages are successful or not. So depending upon whether you have to ignore or you have to take care of this, you can go ahead with merging, or you can cancel this merge, fix the issue, and only merge when all these stages are successful. So I already created a repository of the complete Jenkins pipeline and the various steps needed to integrate and install various tools. So I'll be sharing this pipeline link, the Git repository link in the description. So you can see I've given installation instructions on how to install Jenkins, Nexus, SonarQube, email server, etc. And also the pipeline steps snippets. Let's say you want to start everything from scratch. You don't want to copy the whole pipeline, but you need some snippets so that you can easily copy some part of your Jenkins pipeline information. So you can easily take these snippets and you can use them. So you can see here I have agent template created, build options, git clone template. So how to run your Maven build your container image. So I've used all these snippets and I've given here so that you can easily copy and paste. And not only that, the actual link to the documentation from where I have taken this snippet is also given. So in case if you need further information, you can just click on these links and you can refer the official documentation. As you see, the Nexus stage needs some configuration so that I can push my artifacts to the Nexus repository. So this complete script or the complete pipeline snippet has been taken from this blog over here, which is from official Sonar type itself. So not only this, I also have some curl commands to send your artifacts to Nexus, send your status to GitHub, and how to write small functions in your pipelines, how to call those functions, how to do the actual Helm deployment, post build actions to send email notifications, how to write a custom Docker file for building your application, how to write a custom Docker file with all the CLI tools. Let's assume I need Kubernetes and Helm CLI tools. So what I can do is I can create my own container image that has both these binaries. Of course, you can use the existing CLI images. So if you want to create your own CLI image, so I also have the method of creating a custom Docker file for that. And I also have Kubernetes deployment and service file to deploy my application, and also how to create Helm repositories in Nexus, how to push your Helm chart in Nexus, how to how to pull the Helm chart from Nexus repository, which plugins I've used, and some reference materials. So everything is given in this Git repository. So if you wanted to implement an end-to-end Jenkins pipeline, so this repository comes in handy. And there is one more file called this Petclinic kubernetes.groovy, which is basically the complete declarative pipeline. So I've named it Groovy so that in my Visual Studio Code some syntaxes gets highlighted. So this is the complete pipeline. So this is quite long because we have used so many integrations, so many various ways of implementing and interfacing various tools. So there are almost 260 lines of your declarative pipeline, but don't worry, everything is actually simple. And in fact, so once you have enough practice, you can even reduce the number of lines in this pipeline, or maybe someone can come up with much better version of this pipeline. So everything is possible, but I have taken the long way. That means I wanted to explain everything from scratch, so maybe the pipeline is so lengthy. And the example project that we are going to see is this Spring Petclinic project. So it has a lot of dependencies, so it will be useful in understanding how the Maven based application will be deployed. And what I did is actually I forked this repository into my own account, and I made some modifications like having the Docker file and Jenkins file. So Jenkins file in this repository is pretty old. You should not refer this. So I'm going to give the end-to-end declarative pipeline, so you can replace the existing one. And this Docker file again I've given in my actual repository. So if you go back to this end-to-end pipeline repository and see the readme, so I already gave the Docker file to build this Spring Petclinic project. The same Docker file I've already put in my forked repository. So if you want to start from scratch, you have to fork this repository, or else you can just clone my repository and you can work with this. So this is the complete end-to-end pipeline that we are going to see in this demo. So there are a lot of stages, lot of tools, and their integrations are needed. So the flow is like this. So once the developer pushes the source code to the Git repository, your GitHub will send a notification to the Jenkins over Webhook, and Jenkins, once it receives that notification that there is a new push event occurred in the repository, so it will immediately build the source code and run the test cases and scan the source code for any vulnerabilities or any issues. So once this is done, it is going to send those results back to the SonarQube server, where SonarQube will analyze your complete analysis results, and it will calculate the quality gate information for us, and then it will see whether the software quality is good enough to go to the next stage or not. If the quality gate is failed due to many issues in your source code, that information is sent back to your Jenkins itself. That means once the SonarQube finishes the analysis process, it is going to send the quality gate information back to your Jenkins. Now Jenkins will receive whether the quality gate is passed or quality gate is failed. So if quality gate is failed, obviously we'll abort this complete pipeline, and we'll see where exactly this quality gate has failed. Now again, that information will be shared back to the developer. He fixes the source code, and then he'll check that source code into GitHub again the Jenkins will receive that notification. It will build, test, and then it will analyze your source code and again send that information back to the server. Again server will calculate the quality gate, and this time if the quality gate is successful, your Jenkins will go to the next process. So in the next process, what Jenkins is going to do is Jenkins going to store the war file which is generated out of the build process. So not only war file, so any build artifact that is generated out of the build process can be stored for future reference. So in our case, since we are going to use a Maven project, so that Maven war file will be stored in the Sonar type Nexus repository, and if you want, you can use it later. But since we will not directly run our application as a war file, we need to containerize it. So in the next step, we are going to containerize our application by taking this war file and containerizing it. And once the container image is basically generated, once it is created, so either you can store it in Sonar type Nexus, or else you can store it in the DockerHub. But in this example, we are going to talk about how to store it in DockerHub, because your Sonar type here runs on HTTP. So here we don't have any HTTPS communication, and Docker needs HTTPS server to talk to and to store its container images. Since Sonar type doesn't have that, we are going to temporarily use DockerHub. But for our war file Helm charts, we are going to use Sonar type. And for this complete application, so whatever Helm chart it requires, so that Helm chart also you can put it in the Sonar type Nexus itself. So once your Docker image is pushed to DockerHub, so the next step is in this process is the deployment. So what we are going to do is we are going to deploy our new image that is generated into the Kubernetes environment through Helm charts. So that's Kubernetes environment is set up in the DigitalOcean cloud, and through Helm charts you can deploy your application to the DigitalOcean Kubernetes cluster. So once this is deployed, so basically you'll have a lot of feedbacks here. So you can send the email notifications back to the Jenkins, whether it's not to the Jenkins basically. So email notifications has to be sent to the user. So here I've shown it to the Jenkins, but here your email notifications will be sent to your user whether the pipeline is successful or failed. So not only this, so at every stage also you can configure the postable actions in such a way that if a particular stage is failed, you can send email notifications to the user. And as we already discussed, so not only the email notifications, even when you open a PR, so even that PR in the PR you can also see the overall status of your pipeline, like where exactly it is failing, what all stages are passed. So if you see, there are 6 different stages and one of the stages failed. From here you can decide whether to close the PR or you can just cancel it so that the developer can work on the fix. So this is the complete end-to-end pipeline. So this is quite complex because we are going to set up everything from scratch, that too on Kubernetes, using Helm charts, and then we are going to see how to configure them so that they internally talk to each other. And we'll also understand like how to work with Sonar type Nexus repository, how to actually create custom quality gates in SonarQube, how SonarQube will analyze the result, what is a quality profile, what is a quality gate, and how to link a custom quality gate to a specific project, and how to create Helm charts, how to store them. So it's a complete end-to-end pipeline. So without further delay, let's get started with the actual practicals. So I'm in the DigitalOcean dashboard. So once you're in the dashboard, you can click on Kubernetes and create a Kubernetes cluster from here. So the default region is Amsterdam, and I'm going to select the default VPC network. Kubernetes version I'm going to select is 1.24, and I'll be using 2 VCPs and 4 GB RAM nodes. So this would cost me $72 per month for all the 3 nodes. Since I already have $100 credit to try DigitalOcean, I won't be charged for utilizing this cluster. and I'll be using 3-node cluster. And here that's it. I can just click on create cluster. So once the cluster is created, I can access it using kubeconfig file. So basically kubeconfig file is here, so you can directly download the kubeconfig file once the cluster is ready. And now we'll understand how to deploy Jenkins on Kubernetes using Helm charts. So for this, we need to have two CLIs first. One is the kubectl CLI and the other one is Helm CLI. Let's first configure them. So let's first download and configure them. So I'll just search for kubectl download. So I'll get links to download it from official Kubernetes documentation. So this is the URL, and from here I can download kubectl for Windows because I'm on Windows, and I can download directly using curl, or else I can download from the releases page. So I'll just click on releases page here and download it to your downloads directory. So here kubectl is downloaded. Now let's download Helm. So let's just search Helm download, installing Helm. Similarly, you can install Helm through curl commands, or else you can directly download your desired version from the releases page. So here I'll be selecting Windows AMD 64 because I am in the Windows platform. So if you're on Linux, so you need to follow your own methods of installing these two tools. So I'll click on Windows AMD 64 and I'll just download it. So here your kubectl executable is downloaded like a file, but in case of your Helm CLI, it is downloaded as a zip file. So what you have to do is you have to just extract it first, and within the extracted folder you will have the Helm exe file. So first what we need to do is we need to move them to a folder and add that folder to a path, I mean the environment variable, so that from anywhere you can run kubectl and exe files. So this is just like adding this particular location of the binary to the system environment variable or the path variable in case of Linux. So what I'm going to do now is I'm going to just take this particular file and then move into a folder inside your C drive. So in case I created a folder called tools, and then I'm maintaining all my exe files over here. Similarly, what I'll do is I'll also take my helm.exe file and I'll move into C drive and tools folder. So not only tools folder, if you want to name it with any other name, you can just name it. And then what I'm going to do is I'm just going to take this particular location like C drive tools, and now what I'm going to do is I'm going to search for environment variable, that is edit the environment variable, and then here I'm going to click on environment variables here. So there are environment variables for user, environment variables for system. So in the user level I can just click on the path and then click on new and then paste your location like C drive and tools. Click on OK. And in the same system variables, right, double click on path, click on add, and just add this and then save. Okay, so here we have added this C drive tools to our environment variable, so that whenever you invoke kubectl or Helm commands, automatically it will be searched. Now what I'm going to do now is I'm going to install a Helm chart. Install Jenkins through Helm chart. So for this, let's see whether our cluster is up and running. So let's go back to our DigitalOcean. So if you see here, my 3x3 nodes are running, and this is the kubeconfig file. So let's download this kubeconfig file into our downloads directory. So basically your kubectl utility finds this kubeconfig file under your home directory under .kube folder. So this is where it will find, but here we have downloaded it into the downloads directory. So now what we are going to do is we are going to open any terminal window. So I'm comfortable with Tabby. So if you want to use Windows CMD or Git Bash, it is completely fine. And now what I'm going to do is I'm going to cd into the downloads directory, because this is where I have the kubeconfig file which I have downloaded. As I said, so if I just run kubectl get nodes or get pods, so basically your kubectl will look for a kubeconfig file in a .kube folder. So it will look for a file known as config. So it is basically under the user's home directory, so /. So your kubeconfig file should be actually a file with this name, but here, so when we downloaded with a file known as this. So just do cat, and this is the actual file. So if you see this k8.yaml file, this is the actual kubeconfig file. Now what I'm going to do is I'm going to cat on this file and I'm going to just redirect into this location, which means this is as good as I'm creating a new config file so that my kubectl can talk to the DigitalOcean. So if you are still not sure what is this k8 config file, this is the kube config file that DigitalOcean gave for your Kubernetes cluster, which will have the server URL, the user related certificates, tokens, etc. Now that we added our kube config file to our config, so now if I run kubectl commands, so I'll be able to talk to the Kubernetes cluster running in the DigitalOcean. So currently there won't be any resources because we haven't downloaded anything yet. Now the first thing is we need to install Jenkins. Since we already have the cluster, we already have the Helm and kubectl CLIs, let's see how to install Jenkins. So for this I'm going to refer the official Jenkins chart from artifacthub.io and I'm going to search for Jenkins. Okay, so here this is from organization Jenkins itself, so let's use this link. So for installing Jenkins, I should use Helm CLI, which I have already downloaded. So I need to add this Helm repository called Jenkins, and this is the URL to this repository, and then I'll run Helm repo update to update the package. And then what I can do is I can install it directly by running Helm install, and this is the repository name, and inside this repository there will be a chart called Jenkins. So what I will do is first I'll add the Helm repository. So I'll go back to the terminal and do Helm repo add Jenkins and the name of the repository. If it is already existing, so it will say that it is already there, and after that you need to do Helm repo update. So once Helm repo update is done, so I can directly install Helm chart. So if you directly install Helm chart, the Helm chart will be pulled from the remote location and then it will be automatically installed to the Kubernetes cluster. In our case it is DigitalOcean cluster. But what if you have to configure that Helm chart, like you need to download it and then you have to basically install it, I mean after making some modifications. The first thing is, how do you pull the Helm chart into your local machine? So instead of using Helm install, you can use Helm pull and you can pull this Helm chart. So I'm going to do the same thing. So I'm going to do Helm pull and then the repository / the chart name. So if I pull it like this, it is going to download the tar file. Again I have to extract it. So what if I can directly pull the extracted folder? So in this case I can use --untar. So my Jenkins Helm chart will be automatically pulled into my local downloads folder. And then so you can go into your downloads and open that folder. So if you already have VS Code, you can open that VS Code by using code, and the name of the folder, it is just downloaded. So basically, so you're downloading the Jenkins chart from the Jenkins repository which we just added. So it will be downloaded as the folder name itself. So I'm just opening it in the VS Code. So in the chart you have the values.yaml file and you can configure a lot of parameters in this values.yaml file. So for example, you can change the service type, you can change the image tag, whatever it is, you can just do it. And inside this chart I'm going to make some modifications here. The first modification is I'm going to change the service type from cluster IP to node port. So here instead of cluster IP I should use I'll use the load balancer because I don't have any ingress controller. So if I have ingress controller, basically I would make this as internal service and then use ingress resources to rewrite the traffic. But in this case I'll directly expose it through load balancer. And this service port, so target port is 8080 because your Jenkins runs on 8080. In case of service port, which is the actual incoming port, I'll make it to 80 so that directly using load balancer IP I can access it. So if I use 8080 here, I should use the load balancer IP colon 8080. Again, that's an extra port, I don't want to use that, so I'm changing it to 80. And here inside the same chart already you have Kubernetes agent configured. That means the complete details of the Kubernetes agents, that is your Kubernetes cloud, is already done. So it is done because already when you first run your Jenkins instance, it is already downloading the Kubernetes and all the relevant plugins. Since it has all the plugins, so in the same chart they've already created the Kubernetes agents for us. So in the configuration, if you scroll, so here you can see that agent is enabled to be true. That means automatically Jenkins will configure Kubernetes cloud for us, and the container which is responsible for connecting back to your Jenkins master is using this Jenkins inbound agent image, which is of tag 4.11.2. so here whenever you create a job, so it will utilize a pod. So the first container inside that pod will be inbound agent, and this inbound agent is going to talk to the master over 50,000 port, that is the JNLP port, which is already defined in the same Helm chart. So if you scroll to the top, so you'll have that JNLP configuration here, and 50,000 is the port that is opened on your Jenkins master as well, along with 8080 port. And if you scroll here, we need to also configure the storage requirements for your Jenkins. As you see here, the persistence is set to true, and Jenkins is using 8 GB of space. That is completely fine. Storage class, if you don't use DigitalOcean provides the default storage class. So if I have to get the default storage class of DigitalOcean, what I can do is I can just use kubectl get storage class. So the default one is DigitalOcean block store, which is set to the default. So if you're not using any storage class, it will automatically take from the default one. And I think that's it. So we don't have to do anything related to the configuration. Just save this values.yaml file, and in order to install it, so there are 2 commands. So I can directly use helm install, and next time if I want to upgrade the chart, I have to use helm upgrade. But if you don't want to track whether it is a first installation or an upgrade, so I can directly use helm upgrade command and then use a flag known as -- install, so that if you run this command again and again, so first your helm will see whether the release is there or not. If release is there, it is going to do helm upgrade. So if it is the first release, it is going to ignore this upgrade, and then it is going to do install. So this is how, using a single command, you can both roll out the initial version and also upgrade it. And I need to use a release name. I'm going to just use Jenkins as the release name, and from which folder. So it is basically Jenkins folder, which we just extracted in the first step, and this is the folder which also has the values.yaml file which we modified. Just click on install, so automatically it will install. And all these methods are already available in our repository, so which will be shared in the description. So if you see, I have the installation instructions on how to install, etc., and also once installed, how to get the password and all are also shown here. Now our Jenkins is basically getting installed. So I'll go back to my DigitalOcean. So if you see on the Kubernetes landing page, there is this Kubernetes dashboard. Just click on this Kubernetes dashboard. So it will open the in-browser version of the popular Kubernetes dashboard. From here you can see the list of pods, list of services, etc. So here you have the Jenkins stateful set pod. Okay, so if you see from the cluster, so basically Jenkins gets installed as a stateful set. So if I just do kubectl get sts, so there is a stateful set with only one replica. So that replica is basically coming up, and if you see, it came up and it is in the running state. And there are 2 images it is using because there are 2 different containers. And if I go back to the services here, so you can see that Jenkins is now exposed as the load balancer, and here load balancer IP is still pending, because if you go back to the Jenkins DigitalOcean, and if you go on to this networking section, and if you click on load balancers, so here see the load balancer is getting provisioned for your Jenkins. So this is the same case even with your AWS or GCP or Azure. So automatically, once you select a service type as load balancer, a cloud provided load balancer will be provisioned automatically, and an IP address will be shown. So that IP address, basically you are going to get it in the kubectl get svc output. But even after load balancer is provisioned, so it takes some time for the external IP to get updated here. So let's wait till the external IP comes. And also, once this load balancer is provisioned, you'll also get the IP over here. At the same time, if you go to your dashboard and click on services, so this should automatically get updated here, but it will take some time. So once it is updated, you are going to see the endpoint. So let's wait till it shows here, and after that we'll see how to access our Jenkins. Now you can see here my external IP is shown along with the port number. So what I have to do is I have to just click on this, it will automatically open. So it is saying some decip to site because it is running on HTTPS. What you can do is you can just visit this insecure site, that is completely fine. And now here as a username, it is admin, and the password is already shown in the Helm output here. So whenever you do Helm install, automatically in the notes.txt it is going to show how to get the password. So here for the admin user, you can get the password from the Jenkins pod, but basically here they gave a ROM command. Here they are using service Jenkins, but actually you need to use kubectl exe on the pod. So here you need to go into the pod and then you need to read this particular file, and for that I'll just go into this particular pod. So if I just get the list of pods by running kubectl get pods, so Jenkins -0 will be your first pod. So I'll just go into this pod kubectl exec -it and the name of the pod and --bash, and this will take me back into the shell session into the container. From here I need to cat on this password. So here this is the password. So let's copy this password and then just paste it here. So this is the password, but here this is not the overall password because there is a terminal prompt also. So let's just copy this whole thing here and just paste it and remove this Jenkins at the rate the rest of the part. So this is my password. Just copy this password, go to the Jenkins and then click on sign in. Okay, so this will take me to my Jenkins dashboard. So if you see, this is a fresh installation, but you have some plugins automatically installed. And if you want to use Kubernetes agents as pods, I can go to manage Jenkins and manage nodes and clouds. In the configure clouds, you can see that Kubernetes is already configured. So if you expand the cloud details, so it is talking to the same Kubernetes environment, and then here Jenkins URL, Jenkins tunnel, everything are already configured. So if you don't know how to configure them, do refer to our earlier video on using Kubernetes pods as agents in Jenkins. And here so there is a default pod template. So the default pod template is actually using Jenkins inbound agent. And remember the first container, that the JNLP container, this is the container that is responsible to talk to your Jenkins main controller or the master pod, and the name of the container is called as JNLP. Just remember, because we are going to use this name of the container to run certain workloads in this container. So let's say I wanted to run a particular stage inside a container, and this JNLP container will give me all the tools necessary to run that stage. Then why can't I just use this container itself? So this is the JNLP container, and this is using the inbound agent. That's it. So this is the first container template, and after that there are no container templates because we are going to create our own required containers in the declarative pipeline. So this is the basic understanding that is needed to work with Kubernetes pods as build agent. So in-depth video we have already covered. So now our Jenkins is up and running. So the next step would be writing the whole pipelines itself. So after this Jenkins, so the first thing we are going to do is how to write a sample pipeline in order to understand whether Jenkins is actually able to create a pod as the build agent or not. So if I go back to the Jenkins dashboard, I can click on new item over here, and here I am just going to name this as Spring Petclinic. So this is just the project name which we are going to build, and then this is a pipeline based project. Click on OK. Now we don't have to worry about configuring all of these as of now, because we are going to do everything from scratch in the declarative pipeline itself. So now here the pipeline, I am just writing it here, but if you have the pipeline with the name called Jenkins file, so basically your declarative pipeline, you need to put in your repository with a file name called Jenkins file. So if you see this Spring Petclinic project, so there is this Jenkins file which I already created, which is basically old. So this name is Jenkins file with capital J and no extensions. So if I have this Jenkins file in the repository, so what I can do is I can fetch that Jenkins file from the SCM. So how do I basically write my first declarative pipeline template? So I can just try a simple pipeline here by clicking on the hello world. So this will directly give me a template of running hello world. So let's copy this one and let's start writing from the scratch here. So this is the repository of end-to-end pipeline where you have the Groovy and all. So I'm going to create a new file here, and I'm going to say it as Jenkins file here because this is my pipeline. So the reason why I used .groovy as the syntax is just for syntax highlighting, so that extension is not needed. So this is the pipeline file. So this is just the basic template. So it says a pipeline, and you have async any, which means this particular pipeline can run in any of the available nodes. I have a stage called hello, which is just printing hello world. So this is just the basic one. But here, if you want to use Kubernetes asyncs as pods, so there are other syntaxes. So the syntax is, so if you go back to the repository in the pipeline snippets, I already gave the link to the Kubernetes plugin. So this Kubernetes plugin is already installed by Helm chart. So what I can do is I can just go to this Kubernetes plugin, and I can learn more about this plugin on how to use Kubernetes pod as build agents. So if you scroll to the bottom, so we have done all these configurations. Basically these are done directly by the Helm chart itself. And what I can do is I can define a pod template. So pod template in the sense, so how your pod should look like, how many containers it should have in order to build your particular job. And if you scroll to the bottom, so here basically we'll be using the pod manifest file to define the pod. And there are templates for scripted pipelines, and there are templates for the declarative pipeline. So we are going to use the declarative pipeline syntax. So let's scroll to the bottom here. So it is a declarative pipeline, and in the pipeline as you see here, so I have an agent. So agent is not any like before. So before we have agent any, so this time we will be using agent as Kubernetes, and inside this Kubernetes block, so you have the pod definition file. So basically it is an YAML file, and you will be putting the complete YAML syntax here. So that will define your actual the pod and the containers that should be inside that pod, etc. And here I also have inherit from. So basically what is this inherit from? So this inherit from is very important when you use your internal Docker repository. So what happens is when you define Kubernetes pod as build agent, and if you define only one container image, which is Maven, so automatically your Jenkins will try to create one more container, that is JNLP container, which is Jenkins inbound agent, because this is the container that is responsible for talking back to your master pod. So if you go back to the image over here, so if I define only one container in the pod template, so automatically Jenkins will spin this JNLP container also. But when it tries to create this container, it is going to use the default image, which is Jenkins / inbound agent. So let's go into that also. So it will try to use this image, but the problem is this is in the public repository. So when Jenkins tries to access the public repository from your own internal network, this obviously is going to fail. So how do I give basically the location of my internal repository? So for this we are going to use the configuration which we already did. So if you go back to your Jenkins, manage nodes, manage clouds, configure clouds, and then here, so here I have the pod template, and inside the pod template details you can see the name of the pod template is default, and here the pod template already has a container which is JNLP. So instead of putting a public repository, so I can put my private repository which already has this inbound agent. So which means, so if I refer this pod template default, if I inherit this template into my pipeline, so automatically instead of pulling from the public repository, so it will try to pull from my location from where I can actually pull it. So let's say you internally you have a repository like Nexus repository or some Harbor repository, so I can give that location. Now I can use this pod template name here. So in this case, so instead of pulling the inbound agent from public, so it will try to pull from your own repository so that your pipeline will not break. But let's say you don't want to inherit, you wanted to start from scratch. That means you can also write everything from scratch just like this. So this is an agent template. So I have an YAML template, and the kind is pod. This is the label, so the name of the pod is not needed. Inside the spec here, if you see, I have a container called Maven, and then this is using a Maven based container image. And since this container should not basically stop running, so the command I am setting as cat and tty to true. So in this case, what will happen is, so it will run cat command, but since we are not giving any input to this cat command, so this container will keep on waiting for the command forever. So that means I can make this container run forever. Similarly, if I need another container, and if that container needs to have git install, I can basically select that image. So here Bitnami Git has an image, which has git install, and the same command, that is cat and tty. So here if you see, there are two containers I have defined, but as I already mentioned, so your JNLB container is mandatory. So in this case, what your Kubernetes will do, that is Jenkins, when it is creating a pod, what Jenkins will do, it will add one more container definition. That definition will try to pull the inbound agent also. So this will try to pull from the public repository. So that is the main issue here. Since I have access to the my public repository because I'm running on public cloud, that is fine. So if you are internally working, like you have inbound agent image internally, and if that pod definition is set here with location of your inbound agent that is pointing to the internal repository, so I need to inherit this default template. So that is what they have given here. Now here what I'm going to do is, I'm just going to take this whole snippet here, and I'm going to just start building my whole pipeline. So let's close the Jenkins Helm chart. So here as an agent, so what I'm going to do is, I'm going to open and then close, and within this particular agent I'm going to put my whole Kubernetes template. So I'm going to just indent it so that it looks much better, and then here I need to close the agent part as well. So now my agent section is defined properly. So let's adjust the pipeline so that it looks better. So here agent, and our agent is now Kubernetes. Let's also indent it like this. So your agent is nothing but your Kubernetes pod now. Okay, so your Kubernetes pod with a template like this, it will have 3 different containers. So one it will have JNLB, one it will have Maven, and one it will have Git. So I'll tell you why these are needed in some time. Okay, so let's just run this, but this is looking little bit odd. Let's manage the indentation a little bit. Let's decrease the indentation levels, so you don't have to do this if your indentation levels are proper. So this is not a mandatory requirement, but this will look much better. So that's why I'm managing the indentations. Okay, agent Kubernetes, this is the YAML syntax of your agent, and yeah, so this completes your agent block, and here you will have the stages block now. So here stages, so I have a single stage, and the stage is called hello stage. Okay, and this is having a step known as hello world, which means, so this stage basically will run echo hello world, but the question is where exactly this will run. So here we are saying we are creating a pod as a build agent. Okay, so this pod has multiple containers, like you have Maven, you have Git, and you have JNLP. But where exactly this particular echo command should run, in which container? So this is again important. So you can also set the container parameter here if you go to the official documentation. So I can also run a particular command inside a container by using this container and the name of the container. So if I just take this syntax like this, and in this step, what I'm going to do is I'm going to just put it as a container. So this is a Docker container, but do I have this container name? No, I have a name called Maven, I have a name called Git, and I have a name called JNLP that is by default. So I will run it in Maven. So I'll just name this container as Maven. That means this echo hello, it should run in the container. So just open the braces and then enclose this complete echo command inside this particular Maven. Since this is Maven, instead of running this echo world, let's see whether Maven is installed by running Maven -version. So this has to print Maven version, and since I am running this particular command in the Maven container, so obviously it should not give any error to me. So if I run inside the Git container, so you have the Git, if I run Git container, obviously Git will not have Maven, so this should actually fail. So let's take this complete pipeline and then go to our dashboard, click on the Spring Petclinic, configure, and then click on pipeline and then just paste it here. So here so everything is configured. You have the pod definition and Maven command. Let's click on save and click on build now. So basically once you click on build now, it is going to create a pod with 3 different containers. So you can see it from the terminal. Okay, so let's exit from here, exit from the pod, and then use kubectl get pod so that you will see a new pod. So here you see here Spring Petclinic, a pod is created and with 3 different containers. So it's better if you see from the Kubernetes dashboard. So here it will create, let's refresh this page. Sorry, we are in the services. Just go to the pods. See here, there is this pod with 3 different containers. See here, we have defined Git, we have defined Maven, but we haven't defined this inbound agent because this will be automatically started by your main Kubernetes pod. So Jenkins will automatically inject it. So if you go back to your pipeline and if you click on this, so you can see complete information here. So first it created a pod, and then it scheduled it to some node. You can see it scheduled onto some node, and then it is trying to pull all the container images. So first we define the Maven container image, then we define the Bitnami image, and the last we said inbound agent, and then it will automatically take JNLP as the container name. And you can also see whatever the pod definition we gave, it modified it, it added some annotations, some labels, and the containers. If you see, I have defined Maven and I have defined Git here, and third container automatically it is going to inject your inbound agent image, which is called JNP. So that is the advantage. So automatically it will inject. But the main question here is, so let's say I have a pipeline with various stages, and if I say that every stage runs in a container, so how do I share the data across various stages? Let's say my first stage is Git clone, second stage is building that source code. So if every stage runs in a separate container, and we know that containers are separate isolated environments, how do my cloned source code in one container will be made available to the another container? So for this, Jenkins handles this scenario in a different way. The way is it will create an mtdir volume called workspace, and it is going to mount that mtdir into all the containers. So you can see that it is mounting that mtdir volume into this path. So it will mount in the same path on all the containers. That means if a container writes a data to that mtdir, it is made available to the rest of the containers. So that mtdir is basically will have your pipeline workspace. So whatever steps that you implement in your pipeline, so basically the output of those steps, if it is a Git clone, the clone source code will be in that mtdir, and through volume mounts, that mtdir is made available to all the containers. So that is how your workspace is synced across your complete to all the containers in the pod. Now once your container is started, I mean all the containers of the pod are started, you can see I have this Maven version that has to be executed in Maven container, and then it has printed the Maven version. So this is the first step, that is just to see whether you are able to create pods or not. And now we are going to talk about our first step, that is cloning the source code and then running it in and building it using Maven. So for this, what I'm going to do is I'm going to use Git syntax. So I'll go back to my pipeline or go back to the repository. So here in order to clone the source code, I need to use Git commands. So here I can use the plugin related commands. Also I can directly use Git commands. So if I have to use Git plugin, then my syntax will be like this. So let's copy the syntax. So my syntax will be like this. So I'll show you how to generate this syntax. But if I use direct shell commands, simply I can use git clone and then the URL, that's it. So this is one step. So I'll use the git basically git plugin. So first this one, what we need to do is we need to have git installed. But where exactly git is installed? So in Kubernetes pod, so initially we took a container called git. It is basically using the bitnami git image, so which means git is already there in this container image, which means for my first stage, that is git clone, I can basically refer this container. That means I can run my job in this container. So let's do that. But before that, let's generate this particular command. So how do we do? So basically you can use this pipeline syntax. So you can just click on your pipeline and click on this pipeline syntax and then search for git here, and you can populate the information. So git URL, so which is basically our Spring Petclinic project. So you can just use this particular link and then just give it here, and branch, it is main. So main is the branch inside the Spring Petclinic project. If you see, main is the branch, and then I don't need any credentials because this is a public repository, and then just click on generate. So if you see git, it has generated the git syntax. So if you compare it with the one which is there in this readme file, it is exactly the same. So I can separate the lines like this. After comma, I can use the URL like this. So it's the same thing, only it is in the reverse order. So you can take any syntax. So what I'm going to do is I'm going to take this particular syntax and then I'm going to start writing. The first stage name that I'm going to name is as checkout SCM. So this is the first stage, that is checkout SCM, and I want this to run in the git container. So that's why I'll use the name of the container, and this will run the git image. And after this, what I'm going to do is I'm just going to paste the whole source code which I just copied. So here you have the, so you need to properly close the braces also. So you have a container called git, and then it is cloning the source code. So here there is an extra closing bracket, so we need to close. So this is the pipeline, and these are the stages. So this one is closed here, and then steps is closed here. Stage we need to close. So it is showing some syntax error. So where exactly is the syntax error coming from? So check out SCM, steps, git URL, so this closes your agent, this closes your Kubernetes, so this closes your agent here. So let's indent it properly, and then you have the stages. So let's do it from scratch because it is not properly indenting. So this is for the container, so this is for the steps, this is for the stage, this is for the stages, and this is for the whole your pipeline itself. So let's copy this and then just replace it in your actual pipeline. So let's go back to the pipeline, just configure it, click on pipeline and replace the whole thing. So if there are any errors, obviously it is going to show it here, and then click on save and click on build now. So this will actually So it says there is this main, and then there is some issue here. So branch, so so this is what, so we missed one quote here, so that's why it is not working or showing proper syntax highlighting. Let's go back, configure, click on pipeline, and then click on this one. So you have a stage called git checkout SCM, which is basically running inside your git container, and it is cloning the main branch. So let's click on build now. So this will basically clone your source code. So it will create that async pod first, and then it is going to clone that inside the git container. So that's what it is going to do. So the next step would be obviously building the software. For this we need to use Maven commands, because this is a Maven related project. You can see you have pom.xml and all, and in order to build it, so there are already commands. We need to use mvn package, and after that it is going to generate the zar or var file. So in order to see whether it generates the var or zar, you can see here the packaging format is var file. So this is basically a Maven related project, and let's see how to build it. Basically you can use Maven commands like Maven mvn clean install or mvn clean package to pack your particular software. So let's do that command next. So here if you go to the pipeline, it is successful. You can see that inside a container called git, basically it cloned your repository contents. So you have your repository cloned successfully in the previous step. So the next stage would be the next stage should be basically building the software. So I'll say build software, and this one should be opened and closed, and then similarly you will have the steps here, and I wanted to run inside a container called Maven, because it needs Maven CLI. So what I did is I already created Maven container, and then this container will have this Maven image based out of JDK 11, because the Spring Petclinic needs Java 11 to be installed and Maven installed. So I took an image which already has both of these installed. And now what I'm going to do is install inside this, I'm going to run the shell commands, and the command will be mvn clean package. Okay. So if you want to pass any command line arguments in the form of environment variables like that, okay, so you can pass. So basically if you go back to my Jenkins end-to-end repository, so here for Maven build I passed an environment variable, so -d invites environment variable. So here I'm saying Maven test failure ignore is true, which means if there are any failure in the test cases when I'm trying to compile the test cases, so I want Maven to ignore it and proceed till the last packaging stage. So in this packaging stage, basically your compiled source code is packaged into a var file. So I'm going to use the same Maven command over here. So instead of this, let's run this by putting inside single quotes. So here this will just basically build my source code in the first stage, which is cloning. In the second stage it is building. As I said, using mtdir volume mounts, so your data is shared across various containers. So this is it. Let's copy this and go back to your pipeline and then configure it. At the bottom, just save and then run it. So this will take a lot of time, because this is a very big project, and mvn install or mvn package command has to download all the dependencies. So there are a lot of dependencies and it is going to take a lot of time. So as you can see, the whole pipeline is successful. So it has generated the war file in this location, that is under the target folder. It has generated this war file, and if you scroll through this complete log, you can also see that it has run some test cases and all. So this is about cloning the source code and building it using Maven. So you are just invoking the shell and then running the Maven related commands. So another step now we are going to see is we are going to display the JUnit test cases report in case of your Maven build. Since Spring Petclinic project already have JUnit test cases and those reports are already available, so I can just try to display those JUnit test cases. So here we'll use a concept called post build actions, where after each stage these post build action comes into the picture, and depending upon the result of your build step, like whether your stage is successful or not, you can use post build actions. So for post build actions you can refer the official documentation. So this is the documentation that explains. So here for post build I can have conditions like on failure, success, etc., which means, so if a stage is successful, your post build action will trigger and it will do something. So it can be like sending an email notification, or it can do anything just like your normal stage. So what I'm going to do is I'm going to create a post build action, so dedicatedly for this particular stage. So the post build action which we are going to see is so after these steps, so we are going to write this post keyword, and after that open and close. Here on success, what I'm going to do is I'm going to display the results of your JUnit test case. So how do I use that JUnit test case report? So here I already gave that, so it's not here. What I can do is I can search for JUnit plugin in Jenkins, and this JUnit plugin basically analyzes your test cases reports, and then it will display in the pipeline display page. So what we can do is we can install this JUnit plugin, and then what we need to do is we need to just call this JUnit with the path to your XML files. Basically the test cases will be available in the form of XML files. So for Spring Petclinic also it will have lot of XML files, right? So basically what we are going to do is we are going to call this JUnit. So for this what we need to do is we need to go to manage Jenkins and manage plugins. In the available tab, let's see whether JUnit is installed or not. So it is not installed. Let's select this and click on install without restart. So once this is installed, what I'm going to do is I'm going to call the JUnit here, and here I can so basically inside the target folder, so we'll have the XML files. So but here JUnit will analyze all the XML files, but these XML files are available under Surefire report. So this is the location under the target directory where it will have all the XML files. Like it will I'm asking it to analyze all the XML files under Surefire reports, that is extra folder where your Maven will create. So I'll also put the star here at the starting, so that it will try to find this target folder from any path, and inside that Surefire reports, so inside that you will have the XML files. So if I run this pipeline again, so what is the main disadvantage I'll get is my MVN clean package will try to download all the dependencies. So why it is trying to download all the dependencies? Because every time it creates a fresh container, and inside that container basically it will run your job. So once Maven do not find your dependencies in that container, it will try to download. So usually when you run Maven commands, so inside your home directory, so it will create .m2 folder, and under the repository a location, that is it path, it is going to cache all the downloaded dependencies. But every time when a container is started, it is fresh. That means this directory is empty, so that MVN will always download the dependencies. So this will basically increase your build time. So what we are going to do now is we are going to take a PVC, and we are going to mount that PVC into that particular Maven container every time when it starts, so that first time when it downloads the dependencies, all the dependencies will be stored in that PVC, and again when we try to rerun the build again, since it mounts the same volume, so it will find all the downloaded dependencies. So directly it will go to the compilation, it will not spend time in basically downloading all the dependencies. So for creating for mounting the PVCs, we need to have that PVC already available. So here in the repository you will find this persistent volume claim. So this persistent volume claim says that it is requesting for 1 GB, and that claim name is Maven cache. So what we are going to do now is we are going to just implement we are going to just run this using kubectl apply -f, and this is maven pvc.yaml. so this will basically create a PVC of 1 GB size. So now this PVC I'm going to mount it into the Maven container, but at what location? So as I said, the container will basically use this path. So the home directory is basically the root, so it is root directory. Inside it will have m2 repository. So every time when it clones the external dependencies, that is downloads the external dependencies, it will download into this this path. So what I'm going to do is I'm going to mount my PVC into this path. So for this I'm going to modify this Maven container a bit. So this is a pod manifest file which we already know. So if you read the official documentation, so you can use the volumes section over here in the pod definition. So that volumes I can use it in my pod definition. So this should be at the containers level. So from here I can just start writing the volumes. So here volumes, so you can read the official documentation. So the volume name, it's up to you. So I'm just saying some volume name as Maven cache. So this volume is nothing but it's a persistent volume claim. So if you still not sure, what I can do is I can just open the Kubernetes volumes or Kubernetes PVC, and then you can refer the official documentation on how to create PVC and how to refer. So you can see here, first I need to use the volumes, and for persistent volumes, so I can see we already created persistent volumes. Let's see how to mount it. So here, see here, volume, and then name, persistent volume claim, and claim name. So let's take the same syntax. So name, anyways I already used, so it is persistent volume claim, and the claim name is, so if you go back to your Maven PVC, so we are calling this as Maven cache. So here I'm calling the claim name as Maven cache. So volume also I'm naming it as Maven cache. So if you don't want to call this as Maven cache, you can simply use this name. Now this volume I need to mount it into Maven. So how do I mount? It is under the volume mounts at the container level, so only to the Maven container level. So what I can do is I can use volume mounts, and then I can mount it into a location. So what location? So as I said, it is under the root directory /root, because every container will run with root as the user, under the m2 directory. So we have repository. So this is where basically Maven will store all the local cache, and the name of the volume is cache, since the persistent volume is I am using as cache. So I am using the cache volume to mount it into this container. So every time it writes something into this location, it will be stored in PVC. So next time I can reuse the same cache. And in this example, now we are also using the JUnit test cases. So let's delete this extra text. So JUnit also we are going to print now. So let's copy this entire thing, and then just replace the existing pipeline. So I'll show you the better ways of using the pipelines by checking this pipeline into Git at the end of this tutorial. Let's click on save and click on build now. Again, this will take a lot of time because now we are using PVC for the first time. It is going to download and cache all the dependencies. So next time build will be a little bit faster. And also if you see, first my PVC has to be mounted. So here attach volume succeeded. So my PVC is attached to the particular pod and it will be mounted as a volume into that particular container, which is a Maven container. So you can also see it in the pod definition file. So in the Maven, basically there is this cache which is a PVC, and as I said, for syncing the workspace, so your Kubernetes basically uses the mtdr, so that mtdr will also be mounted as the workspace, which is common for all the containers. So again, this will take a lot of time, so it is since it is downloading everything from scratch again. So meanwhile, let's go through the actual architecture. So first thing what we did is we cloned the source code from Git repository. So we haven't talked about how to use these webhooks, how to push your source code and all. So we'll come at the towards the end. So now I cloned my source code in my Jenkins, and now I ran the build command, and now I am running the JUnit reports. So after this, what I'm going to do is I'm going to analyze my source code. So basically in the build step only I generated the war file, but I will not send this war file to the Nexus repository yet, because I need to run the unit test cases, and also I need to run the Sonar analysis. So if the Sonar analysis is failing, like if the quality gate is failing, so there is no point in storing this war file to the repository yet. So that's why in the next step I'm going to basically run the SonarQube analysis. So now let's talk about how to install the SonarQube. So it's the same thing again. So I'm going to go to this artifacthub.io, and then I'm going to search for SonarQube. So I'm going to select the one which is directly from the Sonar source organization, and here also it's the same thing. I need to add the repository, and then I need to update it. So I'll run both the commands once, and do Helm repo update, so that repo index will be updated. So if you are getting any errors during the update, I'm getting some error because I added a third-party repository, which is Nexus repository. Currently I don't have that repository, so it is still down. So don't worry about that. So in your case it won't come. So in case if I'm getting this is not found, so what I can do is I can get all the Helm repositories, and then I can delete the one which is not responding. Helm repo, I think RM, so this one Helm hosted. So I can simply remove this, so next time it won't give me this error. And the next step would be installing SonarQube by running this, by running Helm upgrade and all these commands. So but I don't want to install it directly. I wanted to first pull this, and I wanted to configure something. So just pull it and untar it directly. So once it is cloned, it will automatically untar. So what I'm going to do is I'm going to just open it in my VS Code to configure it. So I'll open values.yaml file again. So it is a stateful set with one replica count. It is using the community edition, and the service is cluster IP. But what I'll do is I'll make it to LoadBalancer, and I will not touch any ports. So basically for this example I'm not touching any internal external port, so that when I get the load balancer IP, I'll be able to access it on load balancer IP colon 9000 port. Anyways, that will be shown in the endpoint. Nginx is not enabled, ingress is not enabled for this, but if you have an ingress controller and if you're planning to do host based or path based route, you need to enable this ingress. And after this we need to configure the persistence. So these are the limits. Basically limits, I don't have so many limits. Request, it is 2 GB, that is fine. So maximum cap also I'm making it as 2 GB. Persistence enable, otherwise your data will be lost. Sorry, it should be true. Persistence is true. So 5 GB, yes, 5 GB is sufficient. That's it. So Postgres is also true. Postgres is requesting for 2 GB. Persistence, sorry, it is 2 GB memory. Persistence is true, but it is asking for 20 GB, so it is not needed. For database it is 1 GB because I'm just testing it. So depending upon your organization requirements, we need to adjust these persistences. That's it. So let's save this, and then what we are going to do is we are going to install it by running helm install. The name of the release I wanted to use as SonarQube. Basically I'm installing everything in the same namespace, but in organization you'll create a different namespace and then you will install in that separate namespace. So here helm install SonarQube, that folder which we just extracted. So it will automatically install your SonarQube for you. Let's go back to our actual pipeline and let's see. Yeah, see here it is successful, and as a post build step it has analyzed the test reports. So if you go back to your pipeline, so here you should be able to see the test trend here. So it has analyzed those all XML files and it has given, so one of the tests has skipped and 39 that are passed. So you can see the test analysis trend here. And the next step in your pipeline would be doing the SonarQube analysis. So let's talk about how to perform SonarQube analysis and what all commands we need. And before that, let's understand what is SonarQube. So we'll go to the official documentation once. So SonarQube, and this is a code quality and code security code security tool. So it will do code quality scanning by running certain test cases against your source code. So every language will have certain set of scanning rules, you can say. So your SonarQube will run your scan across all those rules, and then it will find out which of these rules are being violated by your source code, and then it is going to point out the remedy for it and the severity of it. So everything will be shown in the SonarQube dashboard. It comes in the form of client server model, where client is known as Sonarscanner, and we know that server part, which basically analyzes your source code results, the scanning results which are sent by your Sonarscanner. So basically you install Sonarscanner locally, you scan your source code, and this scanner will send the result back to the server. The server will analyze the reports and it will decide whether your software is good enough to go to the next phase in your CI/CD. Maybe it is good enough to go to the deployment or not. And in order to see the overall architecture, you can refer this particular documentation directly from SonarQube. And there are multiple ways you can install Sonarscanner, that is local CLI tool. Either is you use the direct binary or you can use the Maven plugin. So here we are going to use the direct CLI, that is the Sonarscanner CLI, but here we do not install it. We are going to use the Sonar container image, but let's see how we can analyze. So if you go to the scanners part here and if you click on this Maven, so basically your Sonar will export a properties file, which is sonar-project.properties file. So that properties file will have certain details like the location of your source code, the location of your test cases, in which language your source code is written, and all those steps. So depending upon that only, basically your Sonarscanner can scan your proper source code from proper location, and it can scan the proper language. So we will if you see scanner overview, so basically it will need that file, and let's see how that file looks like by Sonarscanner for Jenkins. So here it is not given. Yeah, so you can see here when you click on Sonarscanner for Jenkins, and so it is basically running the Sonar analysis by taking the Sonarscanner tool, and it will run your Sonarscan, and then once it is done, it is going to send it to the results back to the server. And here, so it is, this particular stage is invoking the binary of the Sonarscanner. So here this binary should be available. So in case if you're running as a container, inside the container that binary should be available, and to that binary I'm invoking that binary along with this block of code. So I'll talk about why this block of code is needed. Basically this block is needed so that when scanner completes its job, it can basically send the results back to the server. So if you see the repository, so I have the Sonar scanning stage, where what I'm doing is here I'm invoking this Sonarscanner binary and I'm giving all the properties here. So basically these properties should exist in your repository with a file called sonar-project.properties, or else you can directly give them to the scanner as an environment variable, because -d is nothing but the environment variable. So this project key, project name are to be created directly from the server, because we need to create a project in the server and we need to refer these details in the scanner configuration. And the first question is, how do I invoke the scanner? So here I can just use the Docker image, and inside the Docker image what you can do is, if you want to find this Sonarscanner location, you can simply type which sonar-scanner, then automatically it will give this. So I did a little bit of research and I found this location, so I'm going to do the same thing. So but first before that, let's see whether Sonarscanner is installed or not. So I'll go back to my Kubernetes dashboard. Now you can see here SonarQube has installed along with its dependent database, and if you see the services here, your SonarQube is now available on the load balancer IP on port 9000. Just click on this. So this is the Sonarscanner the dashboard. So I can log in with admin and admin as the password. So here admin and admin are the credentials, and after that it will ask you to create your own password. So I'm just creating admin123 as the password for simplicity, and click on update. So now, as I said, the first step in Sonar server is you need to create a project. So I can create a project manually, and here I'm just saying that project name as Petclinic. So automatically key will also be selected with the same name, and here I can scan this separately. Okay, so here, as I said, you can scan the project in your local machine through Sonarscanner, and that scanner can be a Maven plugin or it can be a direct scanner tool. And so once you click on that project, so you can immediately go back to the project, so you don't have to complete that whole configuration. So just creating the name is sufficient, so you don't have to go and configure any of these details. And in order to see what are the configurations that this project is using, you can go to this project information. So you can see the quality gate it is using is SonarWay, which is the default one, and the project key is this one, but you don't get any more information. And you can also see the project settings here, general settings, quality profiles, quality gates. So let's understand what are these quality profiles first. So quality profiles are the list of rules SonarQube maintains for each language. Let's say I have a Java source code, and I know 200 different rules. I can scan my source code and analyze it. So those 200 rules becomes the profile. So for every language, SonarQube has a profile which is known as SonarWay. So you take any language, there is a SonarWay, but some of the legacy applications may not able to abide by the all those defined rules in the SonarWay. So you may have to skip, or you may have to remove certain rules. So for this you need to create your own set of rules. So those set of rules, we call it as a custom quality profile. So you can tag a project with a custom quality profile, or you can just use the SonarWay, which is a default one. So in many cases we use default one, because default ones are the ones which has all the rules. And what is this quality gate is, let's say you have a source code and you scanned against 200 rules. So now these 200 rules will analyze different properties of a project, like how much of the test cases are covered, which we call it as code coverage, or how many duplicate lines are there, how many violations are there in the form of the function, maybe the naming convention violations, or having so many if else conditions. So there can be anything. So here the quality gate means, so till what level, so your source code can be violated. Let's say I want the duplication lines not to cross more than 10% of the overall source code. Now I want my duplications not to cross 10%. That means I'm putting a gate value here. So that means if my duplication lines crosses more than 10, like the current value is 11, that means it is a violation. So which means gates are closed. So which indirectly indicates your source code is not that good enough to go to the next stage. So quality gates indicates these rules. So if you go to the quality gates, so there is this Sonar way. So Sonar way says that your code coverage, it should be if your code coverage is less than 80%, then this is a violation. Your code coverage should be always greater than 80%, which means your test cases for your overall source code should cover more than 80% of your source code. Like duplication, they should not be greater than 3%, and maintainability, it should not be worse than A. So these are the various rules. So by default, when you create a project, it will automatically get tagged with the Sonar way. That means it will be analyzed according to these limits. Now let's see how to include SonarQube. So the first step is creating a project in the server, which we already did. Now we need to invoke the scanner on the source code. So I'll go back to the Jenkins file. So next stage that I wanted to define is Sonarscan. So for this I know that I need to run it in some particular container with CLI with the Sonarscan CLI. So if you go back to your DockerHub and if you search for Sonarscanner, so this is Sonar source Sonarscanner CLI. So this is the image which already has the Sonarscanner CLI. So let's take this particular image. So what I'm going to do is I'm going to create one more container. So for this I'm going to copy the existing container like this, and then I'm going to name it as basically some Sonar or something like Sonar CLI, and the image I wanted to use as this image. And the command and all remains the same. So just remove this docker pull commands. So the command, the TTY, everything is same. So now within the Sonar's CLI container image, I need to run all my steps. So I'm going to create my steps, and inside the container, so inside the container Sonar CLI, which we just created. So I'm going to run commands. So within this command, first I need to invoke the Sonar CLI. For this I'm going to run a simple command, which is basically which Sonarscanner, because I wanted to invoke the exact binary. So I don't know whether this binary is added to the path or not. So for this I wanted to just check the path. And doing this basically I'll also have to invoke the rest of the stages, but I don't want to invoke because I just wanted to find the Sonarscanner CLI location. So for this what I'm going to do is I'm going to disable these stages temporarily by using when conditional statement. So I'll say when expression. So this expression, what I'm going to do is I'm going to use the expression as false. So I can also write it in a single line like this. So when expression, I can just set it to false, which means this particular stage will not be executed because I made it to false. So conditional, I'm putting it to false. So similarly I can paste this condition even for the software build also, because this is also not needed. And the third step it is Sonarscan. So what I'm going to do is I'm going to make it true. So even if you don't write this statement, it is anyways it is going to execute, but since I'm using when statements for rest of the others, so I'm just putting it here also. So let's copy this whole thing and just copy into your own pipeline and run it again. Just configure pipeline, just replace this entire pipeline, click on save and click on build now. So this will create now a pod with 4 different containers, because we already defined a newer container which is Sonarscanner CLI. So it will skip rest of the steps, and you can see with Sonarscanner. So this is the location. So this is the actual scanner path. So we need to invoke this one. And when you install Sonarscanner, Sonar server, so first what we need to do is we need to go to manage Jenkins, configure system. So inside configure system we need to add those details. So we need to go to the location. See here you will not find the Sonarscanner because we did not install that plugin. So we need to go to manage Jenkins and then manage plugins, go to available and click on SonarQube. So this will basically install that Sonarscanner plugin. So we don't use this plugin, but it gives certain configurations so that are mandatory. So once this is installed, I'll go to manage Jenkins, now configure system. So here you will find a Sonar server. So I'll click on add Sonar server. So the name of the server I wanted to use as Sonar server. So this is the Sonar server. It's just a name. And the server URL, basically you should give the Sonar server details. So this is your Sonar server till port 9000. So what we need to do, we need to give that here. You can ignore the slash, extra slash, and the token. So I need to add a token because I need to authenticate myself. So for this I need to use the user token. So I can see in the drop down there are no tokens. Now I can add. So unfortunately you cannot add from here because this is not working. So till here you can just save it. Now I'll go to manage Jenkins, go to manage credentials, click on Jenkins, click on global credentials. So here I'll create a credential. Before that, let's create a user token. So I'll go to my SonarQube homepage, go to administration, inside the security go to the users, and here before creating the users, so let's click on the global permissions. So here, so I am the administrator, so I need to have the permissions to administer the platform, and also creation and using the quality gates, execute analysis, and also create project. So first you need to check all these options, and then you need to go back to the users. You are the administrator, or else you can create a new user for yourself, which we already covered in the Sonar sessions. And now what we are going to do is you're going to click on tokens, just create a test token valid for 30 days, generate, and this is the token. So here this token, once it is closed, you cannot do anything. Just copy this token somewhere for future reference. And this is a secret token. So I need to go to my Jenkins, in the add credentials I need to make it as secret text, give your secret, and the secret value I'm just giving it as some Sonar. This is just an identification. Now click on create. So my Sonar server details are stored. Now let's go back to my dashboard, go to my project. So here I need to generate a syntax basically. So if you go back to my repository, so here I'm invoking that binary which we just found out, but once the analysis is completed by this block, okay, so usually the data has to be sent to the server. So the server details, I'm just injecting them as an environment variables through this particular block. So this is a with block, so that is responsible for sending the information to the server. So how do I generate this? So go to your pipeline syntax generator, and then here just search for with SonarQube. It has with env and all, wait for quality gate and all, but with SonarV it is not being shown here. Okay, so you can refer the official documentation here. So what they are saying is once you have the global tools configuration, and then so you can use the credential ID we provide with Sonar env block. Okay, so you can use the server details to scan. So what we can do is basically there is also a link which I have given. So here so you can refer both these links. So from here also they gave all the options here. So if you go to the next step, so everything is already given here also. So I'm just going to copy paste this whole thing. So here with Sonar env, with SonarQube environment, so credential ID we stored it with the Sonar. Installation name is also Sonar server because we just configured. So let's copy this whole thing here. So this one, so this should actually go into, so it should replace this sh command because we used sh command just to test it. So let's copy this whole thing and also indent it properly. So this should go here. So with Sonar env, and then so it is the container, so this is at the container level, and this is with Sonar env. So now our complete thing is covered. So what it will going to do is it is going to run the Sonarscanner, and since the project name which we created in the SonarQube is also the Petclinic with the same name, so we are using the same name, and then it is going to scan the src main because your main source code is in the src folder inside your project, and your test cases are in the src test cases. Your binaries are under the target. The language which Spring Petclinic is written is Java, and the rest of the configuration. So let's take this whole thing. But for running the SonarQube analysis, so we also need to clone the source code. So I'm going to make this as true again, and build software also I need to make it as true, because if I make it as false, so what will happen is here we are also analyzing the Java binaries under the target folder. So the target folder won't be created unless we build it. So we can build that source code also. So here we added the Sonar CLI, and within that Sonar CLI, basically within this with SonarQube env block, so we are just running our actual Sonarscanner. So let's paste this inside the pipeline. So configure it and go to the pipeline, just replace this whole thing and click on build now to build it. So basically this SonarQube env should be generated. So let's see again why it is not generated, why it is not shown. Maybe we have missed. So let's click on pipeline syntax generator and let's search again. It should be available with Sonar env. Otherwise if it is still not coming, so what we'll do is we'll restart our Jenkins instance. So this is not shown here, so it should be available somewhere here. Okay, let's see whether this is actually failing the pipeline or the pipeline is successful. So you can also see that build is now faster because already we have used PVCs. So PVCs are actually mounted, so your dependencies will be reused. And you can also see that Sonar scanning stage is also successful, and it has run the analysis and it has sent it to the server. So you can see the server in the you can see the analysis results in the server. Let's go back to the projects here, and if you see the Petclinic project, because this is the name, there are 42 bugs and the code coverage is 94.1 and there are 0 duplications. So here the quality gate is passed. So this is well and good. The question here is so we have created a pipeline, so your scanner scanned it and sent the result back to the server. But the thing here is I'm not able to get the quality gate information back to the pipeline, so that depending upon the quality gate information I'll decide whether to fail the pipeline or to pass. So quality gate is passed, but how do I get that information? So I can make SonarQube talk to Jenkins over the webhook and I can read that information. But before that, let's see how to modify this quality gate, that is a default quality gate, so that this particular pipeline, this particular scan will fail. So here if you see the the Petclinic, it is having the code coverage of 94.1, but the SonarWay quality gate, if you go to the quality gate which is SonarWay, it is just checking the 80%, but my Petclinic project is giving 94.5, that is it's an absolutely fine. Now what I'll do is I'll go to this quality gate, click on create to create a new quality gate. I'm just naming it as my QC, And here I will add a condition saying that on the overall code, so if the code coverage is less than 98, I mean it is quite high, so if it is less than 98, I want this gate to fail. Okay, so I created a quality gate with this one condition, and I'm attaching it to, if you click on this without, so this particular my quality gate, new quality gate, is not attached to any. So without, there is one project, so I'll just select this. So which means, so I tagged this quality gate to my Petclinic. So my Petclinic project will now use this myQZ instead of the default Sonar way. And also I need to grant permissions to the administrator, so that administrator can actually use this, so they can use this my quality gate also. Okay, so you can also verify it. So you can go to the projects, you can click on Petclinic, inside the project information. Now you can see that quality gate being used as myQZ instead of Sonar way. So let's rebuild this pipeline again and see whether this time it is failing or not, because I set my quality gate to have the code coverage of 98, but my Spring Petclinic is only giving me 96.1. So let's see the log and wait. Now you can see that pipeline is successful, but if you go back to your Petclinic and if you check the quality gate, basically it is failed, because so here the overall code is having 84.5 the overall code coverage, and you are requesting for 98, which is absolutely not possible. So 84.5 code coverage is less than 98, but here the pipeline doesn't know that information, because the main the role of this particular pipeline is to send the result back to your server, and the server details anyways we configured in the global configuration. So once the server receives, so it will fail at the server end, analysis will fail, but the pipeline doesn't come to know of it. So we need to wait for quality gate. So how do we wait for quality gate? So if you check the official SonarQube documentation, so they already gave an API. So basically you can use that to get the quality gate information. So I can define a stage called quality gate, and inside that steps, so I can call this wait for quality gate, and then abort pipeline to true if the quality gate is failed. And also I don't want to wait for so much of time, because at the server side the processing might take some time before getting the quality gate. So I will wait only for maximum 1 hour. So after 1 hour, if the quality gate is not coming, so basically what I'll do is I'm going to abort the pipeline. So I'll just copy it here, and then I'll paste it here, or else what I can do is I can create a separate stage here. So this stage I'm just calling it as wait for quality gate, and here I need to define the steps again. So these steps again I need to run it in the Sonarscanner, the Sonar CLI container. So because I need that binary, so here so inside this what I need to do is I need to just copy that logic, that is timeout and wait for quality gate. So I'll just copy it. So within this timeout, so timeout of 1 hour, I'll basically wait for quality gate information. Let's delete all these comments. So I'll wait for this quality gate, and I'll abort the pipeline. So if the quality gate is basically failed, so within the timeout of 1 hour I'll wait. And also, so what I'll do is similarly I'll also use this when expression so that I can control which steps I can run during the development phase. So this one should run, and after that quality gate information should also be calculated, and this information has to be sent. But the question is, so once your scanner sends the results back to the server, the server will process it. So server will process the results, but where do the actual results will be sent back to the Jenkins? So how do the server know where to send the results to the Jenkins? So the server should have that information, like it has to connect to this IP address to send the results. So for this what we need to do is we need to create a webhook in in SonarQube, so that when Sonar completes the analysis, so it triggers that webhook saying that the analysis is completed and this is the result of the quality gate. So I'll go to the administration, go to configuration and go to webhook, create a new webhook. So here the name of the webhooks, I'm just writing it as Jenkins name, so you can use your own name. So the URL, it has to send to your Jenkins, so it should know the Jenkins URL. And after this you need to use word called SonarQube -webhook. So this is like GitHub -webhook. So we need to use SonarQube -webhook and click on create. So automatically once the analysis is completed, basically it is going to send the data, and now your pipeline can read that information. So I'll just copy this whole thing and replace the existing pipeline. Just save it and click on build now. So now again this will take some time. So let's now talk about the next step. So let's say we got the quality gate information, maybe it is yes or maybe it is no. So if it is yes, the next step that we need to follow is storing our war file to the Nexus repository. So the next step in the process is to create a Sonar type Nexus repository. Since this will take some time, so let's meanwhile just install Sonar type. So I'll go to the same artifact hub.io again. So I can just search for Nexus repository to see from where I can install. So here this is the Nexus repository from Sonar type, and it's the same thing. So I can just add the repository. So where is this repository link? Yeah, so add the repository and then use repo update, so that it will be updated. So Helm repo update. And after this, as usual, so we need to just pull the repository, the Helm chart, and we need to untar it. So what is the name? So basically the name is Nexus repository manager, but where exactly it is given? It is given like this. So once extracted, this is the folder name here, this one. So we need to take this and run helm pull name and then --untar. So it says already exists, so maybe I already have, so I'm deleting the existing one and I'm just pulling it. So once we pull it, as we know, so we open in the VS code, and as usual we go to values.yaml file and see the service values and all. So Nexus port is 8081, and you can also change the service type. Here service type is cluster IP. No, it should be load balancer. And after that, persistence is true. It is setting to 8 GB. That is fine. So it's a very small configuration file, and also Nexus port listens on 80, so that we already know. So everything is set. So that is the only change we need to do. So then Helm install. So the release name I'm using it as Nexus, and the path, it's a folder, so it should actually install. So now let's go back to our Sonar pipeline and see here. So it calculated the quality gate at the server end, and here my pipeline is waiting for the quality gate, and now you see the quality gate is error. The reason why it is error is you can see after the analysis, SonarQube has sent that information back to my pipeline, and pipeline failed because the quality gate is failed. So you can see if you go to the webhooks again, and if you see the Jenkins webhook, so this is, so I need to refresh. You can see the last delivery is successful, and if you click on this, you can see the complete JSON payload that SonarQube sent to Jenkins. So here the quality gate it is using is myQZ. It is saying the status is error. The reason is your coverage is less than 84 when the error threshold, that is custom quality gate, you set it as 98. So it will clearly say that your quality gate has failed. That's the reason why your pipeline is also failed, because basically your pipeline got that information through the webhook. So you can also see that it is failed. So that is about SonarQube. So now every time you scan, so it will just calculate the quality gate and it will send you result back. So depending upon the quality gate is fail or success, you can actually go to the next step. So our next step is pushing our war file. So here, once you containerize any application, so obviously you're going to version control your container images only. But here I'll also show you, in case if it is not a container based application, if it is a normal application, so what you need to do in case if you want to store the war file. So let's see the next step in this process. Okay, let's see first whether your Nexus is installed or not. So here, if you go to the pods, Nexus is installed, but the service is still in the pending state, because a load balancer is being provisioned for this Nexus. So once the load balancer is available, so I'll get the IP here. Now let's also understand what are the various things I need to do for the Nexus. So basically Nexus will store the war files, container images, Helm charts, etc. And in this demo we are going to see two different ways of storing the war file. So one, we use the Nexus plugin. The other way is we'll use the Nexus APIs to push our war file directly to the Nexus repository. And here I also have the blog post that clearly shows how to push your Maven artifacts, like your jar file, or it can be a war file. So there is a documentation already available here. So once you set up the Nexus, so you can create a repository, which I'll show. So they've already given this complete end-to-end pipeline. So what they are saying is, so here I need to first decide whether it is a jar file or war file. So they are reading a pom.xml file and finding the packaging format, whether it is a jar file or war file, and then they are searching it in the target folder. So in the target folder, obviously once you do mvn package, so you should have your war file or jar file. So what they are doing is they are going to find whether that particular path or that particular file is actually existing or not. So even after your Maven package command, due to some issues, if your source code, the compiled source code is not packed, so your war file or jar file will not be generated. So in case it is generated using Nexus Artifactory Uploader API call, so what we are going to do is we are going to upload our war file along with its POM file. So along with the project POM file, we are going to upload it through this API call. So here you are going to set the Nexus version, Nexus protocol, whether it is HTTP or HTTPS. What is your PROM group ID? What is your artifact ID? What is your version? So these are called GAV parameters in case of Maven. So once you store, so if you have to store them, you need to store at a proper location. So for this, your GAV parameters are absolutely needed. And if the artifact is not found, basically there is an else condition, and this will basically fail your complete pipeline. This whole thing has to be put under the script, because this is using the Groovy syntaxes. Okay, so this is about a Nexus. Now let's see whether Nexus is up or not, and let's refresh this service. So services, it is still provisioning, so you can go back to the load balancers. So here load balancer is still in the provisioning state. So we'll see if there is any issue with the pod also, so why this is not provisioned yet. So let's go to the list of pods here. So you have the Nexus, it is already running. So let's see if there are any issues by seeing the logs. So here failed scheduling. So why it is failed scheduling? Readiness pro failed, connection refused. As immediate persistent volume claim, 0/3 nodes are available. Attach is already succeeded. Liveness pro failed. Why it is failed? Let's see. It's still in the running state, but services are not coming. because the readiness probe failed. Let's say kubectl get pod and just see the logs of your Nexus. So everything is working properly. Let's get the services. Nexus load balancer is still pending. So let's go back to the load balancer services. Yes, it is now provision, and this is the Nexus repository IP address. Let's copy this one, and then here I can open it under port 8081. So here 8081 because that's the service port, and this is the load balancer IP address. So usually you need to change it to some 80, or you need to put it on reverse proxy so that you can access it on 80. Now click on sign in, and here the password is admin, sorry, the username is admin, and the password should be under this directory, under this path in the Nexus pod. So what I do is I'll exec into this pod. So this is the Nexus pod. I'll use exec -it, and then I'll use --bash to exec, and then just use cat to find the password. So this is the password. I'll just enter the password. It will prompt to change it. So new password I'm going to put as admin123, and click on next. Disable anonymous access, next, next. So here I am going to create a Maven hosted repository because I wanted to host those WAR files. I'm going to click on this settings button, click on repositories, click on create repository, and Maven to hosted. I'm going to name this as Maven-hosted. So here I'm going to store only release versions, and that's it. So redeployment policy. So this redeployment policies allows you to store artifacts with the same versions. So if I say disable redeploy, that means only unique artifact versions can be stored. You cannot actually store the same artifact again and again. So for release artifacts, it should be always disabled. For your snapshot dependencies, you can make it to allow redeploy, but for now I'm going to just disable redeploy. So click on create. So now this is the Maven-hosted is the hosted one. So let's now see how to implement this particular step. Okay, so here you have the environment variables like Nexus version, Nexus protocol, your Nexus URL like the IP address and the port number, Nexus repository we have created with Maven-hosted, and the credentials. So Nexus credentials we need to add. So I need to first go to my Jenkins, go to my manage Jenkins, manage credentials. I will add a credential for my Nexus, add credential. So I'll say it is username and password. Username is admin, password is admin123, and for ID I'm just going to write it as Nexus-creds, like credentials. You can use your own name, I mean your any name. So create it. So this is done, and after this what we need to do, we need to install the Nexus plugin as well. So manage Jenkins and manage plugins, click on available. So here I am going to use Nexus platform plugin, sorry, not, it's Nexus artifact uploader. So here I also need to install one more plugin. So this plugin is known as pipeline utility steps. So this pipeline utility steps plugin, so if you open the documentation, so this will actually provide some common utilities. So if I just go to the documentation or the Git repository of this, so let's go back and steps reference on jenkins.io. so directly you can see. So here this pipeline utility steps plugin will provide some common utilities like finding the files, or reading the CSVs, reading the text documents, extracting zip files. So there are certain common steps that you usually do. So this pipeline utility steps plugin will provide the API calls for that. So we need to install that also. Okay, so this is a dependency, because if you see the Nexus, so here we are reading the pom.xml file. So this read maven pom, it is actually from the pipeline utility steps. So if you scroll to the bottom, so here you can see maven read pom. So this particular read maven pom, it will read the pom file and then it will extract all the parameters. So that's the reason why you need to have that pipeline utility steps also. And one more plugin is here. If you click on this this pipeline, so here I'm not able to see the stage level views, how much time it took, and that complete information I'm not able to see. So for this, what I'm going to do is I'm going to go to my manage Jenkins, manage plugins, and then in the available tab, let's search for pipeline. I think it's stage view, yes, and then click on install without restart. So basically it will show you the stage level time it took and how many stages and all that stuff. So let's go back to your pipeline. So now you can see here this beautiful UI where it will show you the number of stages and how much time it took for each and every stage. So let's continue to write our Jenkins file. So now we need to upload the artifact. So what I'm going to do now is I'm going to write another stage. So this stage name I'm just saying as you can call it with like publish Maven artifacts to Nexus, and here I need to use basically I can use any container because this is an API call. So my usual container, which is JNLP container, should actually work for me. So I'll use container. So JNLP is a default one, so I can just use this. And inside this, what I'm going to do is I'm going to just copy paste the whole thing which is given in this documentation. And also I've already given this whole thing here also in the Git repository. I'm going to just paste it from here. So I just pasted here, and so let's properly indent it so that it won't look messy. Yeah, this okay. So inside the script you have the pom, and this is if else. So this is closing. So this is closing, and this is closing this if condition, and one should close the script block, and other one should close the actual container. So the other one should close the stages. This is completely fine. So now here this artifact upload, basically it will take the war file. So it will take the file from the target folder, the war file that is generated out of the build process. And here this Nexus version protocol URL, the repository credential ID. So we need to set it at the environment variable section. So otherwise these variables will not be like 1 2 3 4 5 variables will not be resolved. So for this, at the top of the pipeline, okay, so after defining all the the asins, I'm going to use the environment and then just give the environment variable. So directly you can take it from here, all 4 environment variables, like 5 environment variables. So let's indent it properly. So Nexus version is Nexus 3 because this is the Nexus 3 release, and HTTP is the protocol, Nexus URL. So what is Nexus URL? So it is the IP and the port number. So you don't have to put the the HTTP part, so you can just remove. And also your the URL should not have the trailing slash. And the repository which we just created is Maven hosted, and the credential ID which we just stored as nexus-creds. So this is username and password to talk to your Nexus repository. So obviously now your checkout SCM will continue, your build will happen, Sonarscan will also work, and quality gate. Similarly, I'll also put this particular when condition so that so I can control when to run this and not. And then your pom.xml file will be read. So basically, if you go to your pom.xml file of the Spring Petclinic project, so here you can see the group ID, which is org Spring Framework Samples, artifact ID Spring Petclinic, the version is 9.99 var. So this one will be stored in the Maven hosted repository which we just created. So let's this copy this whole thing, and then let's go back to our pipeline and click on configure. Let's replace the whole thing, and then click on save, click on build now. So again it will take a lot of time. So here in this pipeline, so what we are doing is we are using the Nexus uploader plugin, and that plugin is taking care of basically uploading the artifacts. But so you also have another way, like you can also use curl, and then you can send that artifact. Okay, so what I'm going to do now is I'm going to show the the actual curl command. So usually the curl command in order to upload in any file, it looks like this. You have the curl, and then you can store any file to a particular URL, and you can use hyphen I think upload file, the name of the file. Let's say I have a file known as test.var. So here I can use that curl command, and then upload file test.var to this URL, and also I can use the user authentication in the form of username colon and the password or any token value. So I can use this particular curl command to actually send the information. And also, in order to not to expose the username and password, I can also enclose this in the credentials block, which I'm going to show in some time. So this is the actual the command to upload. So what we can do now is we can follow the same method. So I can upload the file, the var file, which is basically under the target directory. So it will have a file with var. So this one I need to store it into a location. So basically, so I gave the complete API call in the repository. So if you see, I already gave the link also. So if you open this link in a new tab, so here they are saying how to upload a Nexus artifact to Nexus repository, sorry, Maven artifact to Nexus repository through the curl command. So what they are saying is, so you can use your credentials, upload the pom.xml file, and also you need to upload the basically the var file, and here you need to use the Nexus URL, repositories, actual repository name, and the URL, like basically it will have the group ID, artifact ID, and the actual artifact. So this is how you actually push. So the same thing I've given here. So here the curl command and the user details, upload file. So where exactly that target that var file can be found, and then the URL. So it is the Nexus URL, repository, repository name is Maven hosted. So here if you see, I have this org Spring Framework samples. So this information I can get it from here, org Spring Framework samples, and this is the name and this is the version. So the same thing I can use it here. So org Spring Framework samples, and here if you see the URL, I have basically the need for the artifact name, that is this name, the version, and the packing. So I can find it from this one here. So if you use script block and if you read the pom.xml file, from that pom file, if I want to get the packaging format, so it is pom.packaging. If it is group ID, pom.group ID. If it is at the version, it is pom.version. So same thing. So I'm using these variables. So dollar indicates a variable, and I'm reading a variable for its value. So same thing here I've used in the curl request also. So this is the curl request, and basically I am directly curling it to my URL. So this is how you upload a war file with a curl command. So let's go back to our pipeline. So if you see, our pipeline has failed. So if you see, the reason for it is pipeline aborted due to quality gate failure. This is expected. So what we'll do is we'll go to quality gates and my QZ, and let's deassign it. Okay, so let's unassign this one, so that my Petclinic is not using this QZ. So I've deselected it, and now if you rebuild your pipeline, basically it will work, because now my quality gate is SonarWay, which is the default one. So this SonarWay is only checking for 80% of the quality, the code coverage. So basically this should work as expected. So let's now proceed with the Nexus and understand so how the API, the curl command will work. And here, as I said, this curl or any utility needs authentication, but directly you cannot expose the authentication. So for this, what we need to do is we need to take variables something like X and something like Y. So this X will store your username information, the password should be stored in Y. But if anyone tries to read this X and Y, basically they should get only stars. They should not be shown the actual password or username. And then I can refer them using dollar and the name and the dollar and the name. So how do I bind my credentials to these variables like this? For this, I need the credentials block. So we have a credentials block. So what I can do is I can go to pipeline syntax and I can just say with credentials. So we have with credentials. So this is basically binding your credentials to variables. So I wanted to since I already added Nexus credentials, so I'm just using username and password separated, and then as the username I will access it with USR, or maybe it's up to you. So I will just use it as user, and as a password I'll just say it as pass. And then which credential I'm using? Nexus credentials, because this is the credential which we added, which will have the username and password both combined. Now click on generate script. So here, so if I just copy and try to explain, so basically, so there is this block with credential. It is taking my Nexus credential and making my username available as UES here, and making my password available with variable pass. So now within this block, so if I try to use this curl command, and this curl, if it needs the user information, I'll use USR, because this is this, and password I'll use $pass, that is variable. So now no one can see my username and password here, because directly I'm referring from the with credentials block. And even if someone tries to use echo or sh, and if they try to use this, so basically they will not able to see the password. Username anyways anyone can see, but if they try to see the password, all they are going to get is the simple star marks. That's it. So let's do the same thing here. So let's see our pipeline status. So again it is failed. So this time it is failed due to scripts not permitted to use method packaging. So there is this administrator should approve this particular method signature, because inside the Groovy you're trying to read a file and that method is not approved. So we need to go to manage Jenkins, and then if you see this in process script approval, you need to so basically approve it. So this is the approval. So once it is approved, you need to restart your pipeline. So build now. Now we can see that uploading artifact was completed, and it has updated the pipeline status as successful. Now if you go back to your repository, go to this option here and click on browse, click on Maven hosted. So basically you'll have that 99.99 uploaded. So this is the location, and if you try to re-upload again, it is going to throw an error, because this particular repository will not allow redeployment with the same version. So now that is fine. So this is how you upload using Nexus uploader plugin. So what I'm going to do now is I'm going to just make it to false, and let's see how to use the curl. to use. So I disable that stage temporarily. Now as I already shown how to use the curl command, so let's use this curl command with credentials block directly. So for this I need to create a stage, and this stage what I'm going to do is publish Maven artifacts using curl, maybe some stage name, and this will have steps basically. And now this has to run inside a container, but what container? So that's the main question here. So here the container should have the curl installed, so otherwise without curl I cannot do anything. So what I'll do is I'll create one more container, and that container should basically have the curl installed. So I'm going to name this as curl, and if you see online in the DockerHub, you have a curl utility given by Alpine curl. So you can just use Alpine and curl latest. So this is the curl image provided by the Alpine, and rest of the commands like cat and true, that is same. So I'm going to take this name, that is the container name, and I'm going to use it. Okay, so this is the name of the container basically. So curl is the name, and then I'm going to just use my all these steps here inside the container. Okay, so which API call I need to use? I need to use this curl. So let's copy this one, and then let's paste it here. So here the shell script here. So this is a curl with credentials block. So now with credential, so here if you see I can give the username and password with credentials block, because these are binding the credentials to the variables. But how do I get the artifact ID version and the packaging? See, if I want, so I can directly hard code this information, because under the target directory obviously I'll have a file known as spring petclinic -9.99.war, but I don't want to hard code this, because I want this to automatically and dynamically read from the POM file. So for this I can use the above logic, the similar logic, where I'll use the POM dot the read maven POM the logic here, and this will have the POM file read inside this POM. So now POM dot version gives the version, POM dot artifact gives the artifact, and then packaging it will be given here. But the thing is, so this whole thing should be under the script block, because this is a declarative scripted syntax. So it should be under the script block. So whole thing here, it should be under the script block like this. Then only remove this extra here. So then only this one will work, otherwise it will not resolve all these variables. So here we gave the Nexus URL, which is basically wrong. So this is available with a different URL. So I can also take it from here, or take it from the environment variables here, or else you can just refer the Nexus URL environment variable, that is also fine. So I can directly hard code this like this, or else you can directly use the environment variables. I will just show the both. And also this one, this when expression I'll use, so that if I don't want, I can disable this particular stage. So this time I'm setting it as true. So I'm trying with the different approach here. So I enable this step, at the same time I disable this one. So let's run this pipeline. So before that let's edit this pom.xml file in my repository, because my repository will not allow deploying the artifacts with the same version. So I'll edit this pom.xml file, and instead of this 99, so I'll just put it to 7.77, so that it will give a different version. So click on commit changes, and go to your pipeline, just copy paste the pipeline which we just created, and click on save. So click on build now. So this time it should upload the 7.77, but the approach is little different, so we are using the curl command this time. And now let's talk about the next step. So the next step would be Dockerization. So here, so we can store the war file into the Nexus, so that this war file can be deployed into the Tomcat instance if it is needed, or else if it is a containerized based deployment, so what we can do is we can containerize it. So for containerizing it, we need the Docker daemon, Docker CLI, and all that stuff. Okay, first basically when you wanted to contain this Spring Petclinic project, so you need to have a Docker file. So already Docker file is given. So what this Docker file says is, once you have the war file under the target directory, so you can copy into you can use this one basically to run this. So what we are doing, so we're using the OpenJDK image, and we are taking the war file and we are putting into the user bin, and we are running java-jar and that war file. So using the server port as 8080, because the Spring Petclinic project will basically run on 8080 port, so they are containerizing, so they already gave this Docker file, so we are going to use this Docker file. But how do you actually build this container image? So here we have a Kubernetes environment, and in order to build container images in the Kubernetes environment, so there are basically two ways. So one is using Canico. So using Canico you can build container images. The second step is to use the Docker daemon which is running on the Kubernetes node. So let's understand this in little bit different way. So basically, if you have a Docker daemon, so you should have the Docker CLI, so that this CLI can talk to the daemon, so over the socket file. So this socket file is located under var run docker.sock. So this is the socket file which CLI uses to directly talk to the daemon. So now inside the Kubernetes environment, so you have various nodes in the Kubernetes environment. Say pod can schedule onto any of the node. So every node will have a daemon install, and every node will have this file which is docker sock. So if I have to build container images from within a pod, within a pod means within a container. So basically I am within a container, and this is the basically a daemon is running outside. So in case if I want to build a container, that is by running docker build, so I should have the CLI first, and I have to have the daemon. Since I cannot have the daemon running within the container, I'll try to use the daemon which is running outside in the same host. So I have the CLI inside the container, but in order to talk to the daemon, what I'll do is I'll take that var run socket.file docker.sock file from the host, and I mount it into the container in the exact location. So in this case, when CLI invokes docker build or any docker related commands, it takes the help of that socket file, and then it talks to the daemon over that socket file. But directly, I mean it will talk to the daemon which is running outside the container. So it is just like it will think that it is talking to the daemon within the container, but you know that mounting usually corresponds to the host mount. So the file which you mounted is from the host, so that this CLI is indirectly talking to the daemon outside. So for this I need to use a container image which has docker CLI installed. So that is the main use case. But let's see the pipeline status. So here if you see, my curl request is successful. So it is saying I am able to upload the war file. So there are no issues, everything is done. So if you go back to your Nexus repository and if you click on this refresh, so there should be one more called 7.77 with the war file. So this is also done. So let's do one thing. So let's enable this one, and let's disable the one with the curl command. So this is not needed. And now the second step would be, you know, building the container image. So let's start building that stage. So the stage name I wanted to give it as you know, build docker image, and this should have stages. Sorry, it's stage, I mean it should have the steps, and these steps should run inside a container. So this container should have basically Docker install. So how do we do this? So we'll use a Docker CLI image. So let's take any container template here, and then so I name this as Docker. So here in the DockerHub you have an image called docker:/latest, which will have the Docker CLI, but this one should have the access to the daemon. So what we'll do is we'll take one more volume. So this volume type I can basically use it as host path. So the name of the volume I'm naming as I can say Docker sock, and this one should be of type host path, and this path I'm going to use as what is the path? Basically it is var/var/run. So it is docker.sock. So I'm taking a volume, and it's a host path. So from in every host there is this socket file. So this socket file I can basically mount it into my Docker CLI. So under the volume mounts like this. So this Docker CLI, so we'll have the volume mounts like this. So this mount name, as we already said, it is Docker sock, because we defined Docker sock here. And the mount path I can use the same, it is var run docker.sock. So it's the same path. So I'm taking from the host and I'm mounting into a container. So basically that container has the Docker CLI. So now within my Docker container image, I can basically containerize my whole application. So I'll run this inside the Docker, and inside this I can run my Docker related commands here. So I will invoke this shell, and what I can do is I can run docker build. Since my Docker file is within the same, so I need to tag it with my user account and the image name, and the basically I can also tag it with some version. So for this I'm going to use the help of environment variables. So here environment variables I'm going to create few of them, like the DockerHub username and all that stuff. So here I'll say DockerHub username. So I'm going to use my user account details here, and then what you can say, you can just say app name. So app name I'm just going to use as some app name, Spring, maybe Petclinic. So this is the app name, and so this app name, so this image name, so my image name should be actually the combination of my DockerHub username, which we just used here, that is dollar, and then I need to append slash and then plus dollar the app name. So this should actually give me the actual image name. So in order to resolve, basically they won't resolve properly, so you need to just enclose them like this. Otherwise, this is called string interpolation, so otherwise they won't resolve properly, so you need to enclose them like this. So this becomes my image name. So now as the image tags, so image tag should be unique all the time. So for this what I can do is I can use the build number. So build number is the unique number, so that will be available as basically the environment variable. So this build number will be every time it is unique to every build. So this one I will use as tag number, but if you have any other methods, the preferred methods of giving the image tag, you can always use that. So same thing now when I'm building, so what I can do is I can just use the dollar image underscore name, and then colon dollar image and then tag. So this time I also need to put dot, because this is the context path. So image name and image tag, it will create the image. with this particular tag. But usually when we push the images, so we'll push it with both the tag and also the latest tag. So I'm going to tag the image which I'm just putting, and I'll also generate the image with the latest tag. So I'll push both the tags, the one with the actual the tag number and also with the latest tag. So now as the next step, I need to use the basically docker push command. So the docker push command looks like this. Okay, before that I need to use docker login, and I need to use the username with -u something and -p something, but this is exposing my credential. So what I'll do, I'll again use this with credential block. So before that, what I'm going to do is I'm going to basically add my credentials. So go to manage Jenkins and manage credentials, and add them to the global credentials. So here username and password, so I should have my DockerHub username and password. So ID, we can just give any ID, so I'm just giving docker as the ID, and this is generated. So now I can go to pipeline syntax generator, and I can use with credentials, bind the credentials, that is separated. Username, I wanted to call it as user. Password, I'm going to call it as password. I'm going to take it as docker pipeline script generate. So this is the complete block. So now I'll use this block here. Okay, so here this is the block. Then inside the block you need to you can put any shell command. So here I'm going to use this login command basically. So here docker login, and here username. So username is available with $user because I am binding my docker credentials to these variables. Password, it is $pass. And now once the login is successful, so what you can do is you can just use docker push. So within the credential block also you can do, or else outside also you can do. So docker push. So with what I'm pushing, so I'm pushing the image name. Okay, and you need to push twice because you also need to push the latest tag. So just replace the original tag with the latest. And once this is done, so what you can do is you can also use post build actions. So whenever it is successful, basically you can also delete it, or there is I can simply use delete command here. So if you want, you can use post build actions only when the image push, the docker image push and build and push is successful, then only you can run this deletion command. So docker rmi will delete my docker images. So here the main reason why I am pushing the docker images to my DockerHub and why not to Nexus is, so there is a reason. So Nexus by default will only, or Docker client will only talk to the daemon which is running on HTTPS. So there are certain links which I already gave at the bottom of this. So here you can refer the second link. So why this is actually intended. So here Docker always try to push the images to the secure registry, that is one which is running on SSL. But here our repository running on insecure, that is HTTP. So your Docker client will not allow you to push the images. Of course there are alternatives where you need to add the insecure registry and then restart the daemon, so it will allow you to send the images to the daemon. But since we cannot do that because this is containerized based deployments, so I'm just preferring the DockerHub. So in case if you have internal repositories, internal Nexus or JFrog which is running on HTTPS, so you can use that repository as well, so for pushing your images. But for now let's push it to the DockerHub itself. So let's just copy this whole pipeline, go to your original pipeline, and then replace it, save, and click on build now. So here if you see the Docker build is successful. So if you scroll back, so one thing you need to see here is that when we used deploy to Nexus, basically the step failed. So it is saying could not transfer artifact because repository does not allow updating the assets, because we are updating the same 7.77. that means transferring the 7.77 war file twice, so it is not allowing. So you should not do that. So you should always try to deploy a newer one. So what we need to what is the next step in the pipeline is building the Docker file. So if you see Docker build is successful, and even login is successful, and then it is pushed with the build URL. So this is the build number. So your project will the Docker image will be tagged with the same number, and also it will be retagged with the latest, and then both the images will be pushed, and this finishes the pipeline. So this is the Docker build and push. So what we are going to do now is we are going to disable this push to Nexus, because this is not needed anymore. So we'll enable it at the end of the complete pipeline. So I'm also disabling the Sonar stages. So we are only concerned about the building and then Dockerizing and then pushing it to the DockerHub. So the next thing in the pipeline would be deploying this to the Kubernetes environment. So what we can do in this case is we can use the kubectl utility to deploy our application. As we know that Spring Petclinic project runs on 8080, so we already have defined the pod and the service manifest files. So inside the repository, if you see, so already I have the deployment definition, and I have defined the number of replicas. So this is the container template, basically the pod template with one container, and this is the name of the image which we are using on port 8080. So this is the pod label, the same label we are using it as the deployment label, so that it will manage the number of replications. And then service, we are using the load balancer service type. So the incoming port is 80, target port should exactly match the container port. So this, once you apply this manifest file, so obviously it should deploy it. So what we are going to do now is we are going to make some modifications. So I'm going to just clone my Spring Petclinic project into my local machine. I'm going to open a new tab, and under the downloads folder, so what I'm going to do is I'm going to use git clone and the name of the Spring Petclinic project. So it's a very big project, so it takes some time to actually clone. So then I'm using VS Code to open the Spring Petclinic project, and I'll add one file over here. So inside this directory, so I will say deployment.yaml. So inside this file I'm going to put the deployment and service definitions both, so it will be easier for me. So I can just take it from the another repository, because we already have this. So inside this repository anyways I already put both these files, but I want this Kubernetes manifest file, that is deployment.yaml file, to be available in the Spring Petclinic project. So I basically cloned this and I'm just putting it here. So this is the deployment.yaml file, and also I'll change the POM version. So maybe I can change it to something like 1.2 or something. So I'm making both these changes. So if you know what all the git commands you need to use, so you can use. So let's use it. So let's see the git status. So there should be two changed files. One is added, one is the modified. I'll use git add -a, so add everything, and then git commit -m. Commit message, I'll just say added deployment file. So this whole commit message should be in the double quotes. and then just use git push origin main. So main is the branch, so automatically this one will be sent. So now since I have the deployment file in the Spring Petclinic project, so if you refresh this Petclinic, so you have the deployment.yml file with the Kubernetes deployment file. So now I need to have a kubectl utility so that kubectl utility can run this file, and then it can deploy this file. So for this what I'm going to do is I need to have access to a Kubernetes cluster, but we already have the Kubernetes cluster, which is DigitalOcean Kubernetes cluster. And if you see the kubeconfig file, so we already have the kubeconfig file which we downloaded from the DigitalOcean. So this one we will use in order to talk to the Kubernetes cluster. But in order to do this, there is a plugin that we need to install. So in your Jenkins, so you can go to manage Jenkins manage plugins. In the available, so here you need to search for Kubernetes CLI. So if you see the documentation of this Kubernetes CLI, so basically this will provide the environment that is responsible for that will be making your kubectl talk to the correct Kubernetes cluster. So this Kubernetes CLI, if you see, it will provide this with config block, and then it will take the credentials, and then those credentials which it will apply to your kubectl. Basically kubectl will need the kubeconfig file. I don't have that kubeconfig file, okay, so I just downloaded it from the DigitalOcean. Now I need to give this config file to the kubectl. So I will provide this as an environment variable with kubeconfig this block code. So how do I do that? The first thing is I'll install this Kubernetes CLI. So that is a plugin which is giving me that block with kubeconfig block. So basically this one. So I need to store this credential. Okay, the credential is basically my the kubeconfig file. So I'll go to manage credential, I'll go to the credentials part, global credentials. So here I'll add the credentials, and this type should be secret file because that is the file. And then I'll just upload my kubeconfig file. I'll just name it as K8 as the description. Just click on create. So now I've uploaded my K8's configuration file. Now I'll go to pipeline syntax generator, and then here you can just search for with kubeconfig. So here you have with kubeconfig, and then you can select K8's credential here, and then you don't have to populate all this because everything is already there in the kubeconfig file. So if you open this kubeconfig file, so basically you will have the server URL, server certificate, the cluster name, and all that stuff. So we don't have to populate with everything, just click on generate. So now this kubeconfig file it will have this credentials K8. So it is going to inject that config file to the kubectl utility. So now what we are going to do now is, so we are going to create one more step. Okay, that step is known as you can call it as so deploy to Kubernetes, and here so I need to run it in a container. So that container, so basically you should have the kubectl CLI. So if you search in DockerHub for kubectl CLI, so there are actually a couple of the kubectl utility images, but the problem is none of them are working. So I have this Bitnami kubectl, but once I use this Bitnami kubectl, what I found is, so it is not working as expected. And since I need to have both kubectl and Helm to do the Helm deployment, so what I did is I took the Helm binary, so which is this I think it's Alpine Helm. So this Alpine Helm already has the Helm CLI. Then what I did is, so if you go back to my Jenkins end-to-end pipeline documentation, so here I have created my own Docker image with both kubectl and Helm install. So what I did is I taken this Alpine Helm as the base image, and then I used the commands from the kubectl download options, and then I moved the downloaded kubectl utility to the binary location, which is bin, and then I changed the permission so that I can invoke this kubectl, and anyways Helm is also there. So now I named it as this one, this image. So what I'm going to do now is, so I'm going to refer this in one of the container. So here we are using so many containers, but you can also reuse the containers. So here I'm just naming it as something like kubectl or Helm CLI. So I'll use this some name, and coming to the image, so I'll use this image, and rest of the things are common, like your cat command and run command both should be available, because once this CLI starts, you should not close. So I'll use cat and tty to true even for this as well. So instead of this kubectl Helm CLI, you can also use any name. So I'm just using Kubernetes Helm CLI, sorry, kubectl Helm CLI. So now the next command, that is deploy to Kubernetes, should use that kubectl Helm CLI container, and inside this I'm going to just run kubectl apply -f, since the repository will always be cloned, and that repository has deployment.yml file. So if you go back to the Spring Petclinic repository, so we already have the deployment.yaml file. Since we are cloning the repository in the first stage, our deployment.yaml file will also be cloned. And here, so this container, it will run the kubectl, but how do I provide the kube config? So we have generated the script, right? So this with kube config script. So I'm going to just put it here. So okay, just delete the extra block and delete this closing statement, indent it. So this kubectl command should now be enclosed within this kube config file. So this with kube config file will provide the necessary it will inject the necessary kube config file into this image, so that your kubectl can read that config file, and it can apply this deployment. Since here the deployment file is using the latest image, and I already pushed the latest image in the previous step, so what I'm going to do is I'm going to disable this also, so that my build time will be improved during the demo. So after this you need to enable all this, and for this also deploy to Kubernetes also I am just enabling. So I'll enable only this deployment, and what I'll enable is I'll enable the checkout SCM, because my deployment file is in the repository, and even build software I'm disabling it temporarily. So let's copy this entire thing over here, and then go to your actual pipeline, configure, and then replace. So it will clone the repository, and it will try to deploy your Spring Petclinic deployment and service files. That's it. So it's a very simple one. So we container names must be lower cases, no dashes are underscores are not supported. So which means, so here I'll simply use I think dashes are supported, so I'll use dashes. So configure, and then paste, and then click on build now. So this time it should basically clone, and then it will clone the entire repository contents. It will find the deployment.yaml file, and it will try to deploy it. So the next step, it will be like Helm install. So for this we need to create an Helm chart. See now here your deployment and service got installed. If you go to DigitalOcean and if you refresh this load balancer, so automatically it will start one more load balancer for your Spring Petclinic deployment. And also if you go back to the list of pods, so it will also create a pod. It is in the running state, but your load balancer will take some time. So in the meanwhile, let's talk about the Helm deployment. So in case of Helm deployment, so what I can do is I can simply generate a Helm template, and then I can put it in the same repository inside the same Spring Petclinic project. So I can put in the repository, or another way is to put that inside the Nexus repository, so that I will directly deploy it from the Nexus. So we'll see both ways. So first way is let's generate the Helm template, Helm create. So I'm just going to name it as Petclinic, so maybe -chart. So this is just the template I'm creating. Okay, so here it is saying creating already exists, overwriting. Okay, it is C drive. Okay, maybe it is existing and it is overriding. Let's see the actual repository. Inside the actual repository, yeah, I think it is already there. Okay, so it has replaced it, but that is fine. So now if you go to the Spring Clinic, so you have the values file, and then you have the templates, charts. So charts are not needed for us because there is only one chart. So tests are also not needed, and you have the deployment HPA file. HPA file is also not needed. I have only simple deployment and service. So ingress file also I'm removing, service account is also removing. So if you see, I have the deployment file, okay, and the service file and the values file. So if you see the values, so I should give the repository name. So repository name is so I'll just try to deploy the latest image always. So this the Docker name I'm tagging is with what name. So basically, if you see the environment variables, we have already coded it. So it is my DockerHub name Spring Petclinic. So this is the name. So this is the name, and I need to pull it from my user account, and the tag is let's pull the latest one always, and then service account create, I don't need, it is false, and then service type I wanted to use as LoadBalancer. So what is this port? So this port is the, let's see what is this port. Ingress is false, resources, auto scaling, everything is done, and then let's go to service. Okay, go to the deployment first. So auto scaling is not needed, replica count is 1, and then image pool secret, service account is not needed, I'm deleting. Service context, security context is also not needed, and then readiness, liveness, resources, node selector, nothing is needed. It's basically it's a simple deployment file. And here ports name is HTTP, container port is 8080. So that is the only change that you need to do here. And coming to this service, so here the service port, it is 80, but the target port is HTTP. So target port is HTTP means here you see HTTP port means 8080. In the service, target port should match that port. So 8080, incoming port is 80, that is fine. So these are the only things that we need, and these are the only values file. So now my Helm chart is also available. So what I'm going to do is I'm going to push my Helm chart also. So use git add -a, and then git commit, and then git push horizon. So my Helm chart will also be uploaded. Now if you see the previous one, so for Petclinic we simply deployed the deployment and service, and now we got this IP address. Now let's just copy this IP address and try to see. So basically it should open the Spring Petclinic UI, so which means my deployment is also successful. So now since the deployment is successful, so now what we are going to do is we are going to manually delete this. So if you get the deploy and service, because we are going to just deploy it using Helm charts now. So this Petclinic I wanted to delete, that is kubectl delete deploy / and the name of the deployment is Petclinic, and also the associated service svc / and this one. So I can remove it, so it will delete everything. because I don't want to run 2 Petclinic projects. So now what I'm going to do now is I'm going to use the Helm chart. So in the same Jenkins file, so I'm going to repeat the exact stage one more time. So this stage I'm going to say is a deployment to Kubernetes via Helm, and the other one via manifest. I'll just rename it. So the previous one I'm going to put it as false. So the next one I'm going to put it as true. So here instead of using kubectl, so I'm going to use Helm upgrade -- install, and the name of the release is Petclinic. And inside the repository, if you just see, I have the chart with Spring Petclinic. So this is the chart. So it is going to just deploy it from the repository because it is already uploaded in the repository. Just save this file, go to your Petclinic project, click on configure pipeline, and then just save, and then click on build now. Okay, so there is a typo. Instead of upgrade, I just made a small typo. It is upgrade. So there only this change is needed. So let's configure the pipeline to just use this one. And now, so far we talked about putting the Helm chart in the repository. So why can't we put it in the Nexus repository? So this one also we can do. So I can go to the settings tab, click on repositories, click on basically create a repository, Helm hosted, and the name I'm saying it as Helm host, just a name. You can use your own name, I mean any name, and that's it. Helm hosted in one repository. So this can host Helm repositories. So first, in order to push your Helm charts to the repository, we need to add it to the local CLI, and then we need to send the Helm repositories. So I already gave the various steps. So first thing is, if you want to push to the repository, so you can use curl command. So for that, before you need to add the hosted repository first. So Helm repo add, the name of the repo I am adding is Helm hosted, that is the name, and then the URL. So URL is basically your Helm repository URL, and then the repository, whatever is the repository name which we created with the Helm hosted. So this is the actual name of the repository, this is the alias name, so it can be any shortcut name. So let's just copy this command, and so this Helm repo, this one, so if you don't want to basically expose your Nexus credentials, so you need to use the with credentials block. So what we can do now is, so let's see the previous deployment status first, and if you see here, it is successful in deploying the Helm chart. So you can see it is giving me the notes.txt output, which means my Helm deployment is successful. Even if you see the load balancers, so obviously there should be one load balancer being provisioned, so for my new Helm repository. So it will give me the public IP in some time. Now we are talking about pushing our charts to the Helm repository which we just created. So what I can do is, so I can run Helm repo add, and then since I'm running it is in locally, I can just expose these credentials. So basically this should be the user token, not the password, and the IP address and the port number of my Nexus repository. So what is the IP and port number? This is the IP, and I just gave the IP, and then it is 70:80:81. Let's recheck. It's 70:, yeah. So here this is the repository, the same name I created, and this is the alias name, Helm repository. So I'll just add it to my local CLI. So we are adding our Helm repository, and then use Helm repo update. So this is the command. So now what I can do is, whatever Helm chart I just created for the Spring Petclinic, so I can store it. So before storing, I need to just pack it as a tar file. So what I can do is, I can use Helm package command, and then I can just give the name of the package. So automatically it will generate this tzz file. Now I can curl this tzz file into my Nexus repository. So how do I curl is so I've given in the readme file, so I can curl. So let me copy it. So I can curl with the user credentials. These are the credentials of the Nexus repository, and basically this is the proper URL, HTTP, the IP address and the port number, and repository it is Helm hosted, and which file. So you need to upload the file, tzz file, and this is the verbose, so it will just show you what are the various logs. So you can also put it -v at the beginning. So just take this particular command and then you can run it here. So if you see upload file, we are uploading this particular file. Just click on this, so it will actually upload. So it is uploaded. So you can just go to Nexus repository, you can see the browser tab, and what you can do is basically you can browse Helm hosted. So you can see here we have the Petclinic chart. So now we have this Petclinic chart, so I can now directly deploy it from the this Nexus repository only. So what I can do is, so deploy via Helm. So here it is reading it from the repository itself, and then it is installing. So what I can also do is I can also do like this. So here deploy to Kubernetes via Helm. So from Nexus I can say. So previous one I'm making it as false, so this I'm making it as true. So here how do I just fetch that chart from the basically from the repository? So I can first I will uninstall. So I'll do Helm list first. So this bring Petclinic, because before reinstalling we need to uninstall the previous release. So I'll just use Helm uninstall Petclinic. So this is done by the previous deployment, which is this particular step. So now, so what I have to do is since I already have kubeconfig set, so I need to pull from the Nexus repository. So how do I pull from the Nexus repository? First I need to add the repository. So like this, so it's already given. So I need to use Helm repository and this proper URL. So otherwise it won't talk to the Nexus. So Helm repo add this one. So Helm repo add, and then in the next step it is Helm repo update. Okay, and then sh Helm install. Name of the release I'm just saying that's just some test release. So from Helm hosted, sorry, it's Helm -hosted repository, I am downloading Petclinic chart. So what is the name? So you can also go back to the repository, it is Petclinic chart. Petclinic chart. So if you want to replace any parameters like the image name or image tag, so you can also use hyphen set. So if you see your the Helm chart inside the values.yaml file, so in case if you wanted to change the image tag, so what I can do is I can use hyphen set image and tag. If it is name, image.repository. So what I can do is, so every time only the image tag will change. So name obviously it won't change, so I can use image.tag. So by default I can use latest, or else if you build a new tag and if this tag is being called with this image tag variable, so obviously I can deploy that tag also, because it is already uploaded to the your DockerHub in the previous stages, and now in the deployment stage obviously it will try to pull from the repository. But here if you don't use it inside the chart, it is always latest, so obviously you will be using the latest one. So let's deploy it using this way, that is trying to pull from the Nexus repository. So this one again obviously it will be successful only. So let's configure it. sorry, configure it is done, it is built now. Now let's talk about the post build actions, that is sending the emails. So for sending the emails you need the SMTP server details. So inside your organization, if you ask the cloud team or the SMTP team, they are going to give the SMTP server details on what port number they are using and what are the user credentials and all. So for mocking this basically this email notifications, so I'm going to download and install MailHog. This is an email testing tool where if you send any email to this server, automatically it is going to replay it in the inbox. That's it. So there is no from address, there is no to address, so you can't send to other Gmail accounts using this SMTP server because this is a test one. So if you use the server details of this and if you try to send emails to anyone, only this server is going to capture it and show it in the UI. So if you see the MailHog, so it is again a Helm chart. So I'm going to add the repository and I'm going to just do Helm repo update, and after this what we need to do, we need to just pull the image, sorry, just pull the chart and untar it. So Helm pull and use -- untar, and then use code MailHog. So the MailHog has two different ports. If you open the values.yaml file, so it says that 8025 is for the for the communication, that is the UI page. So 1025 is the SMTP configuration port number. That means for SMTP to work, it listens on 1025. For UI, just to see the inbox, outbox, it is 8025. And for this again, so what we need to do is we need to change the service type to LoadBalancer. That's it. And it will work as expected. It won't need any persistences, I hope, because this is a test server. So that is the only requirement. Ingress and all are disabled. That is completely fine. So what I'm going to do is I'm going to install using Helm install. So I'll say it is mail, release name MailHog. Now let's see the previous deployment. So we deployed through Helm by taking it from the Nexus repository. If you see, we just added the Nexus repository, Helm hosted Nexus repository, and we did Helm update, and then we tried to pull it and install. So everything is working as expected. So you can also see the load balancers. So one is the MailHog's load balancer, that is provisioning. So the other one will be the Petclinic project. So you can also go to the dashboard and click on the services. So for this test Petclinic, I think a load balancer is still being provisioned. And for MailHog, it is already provisioning. And now how do you connect emails? So how do you send email notifications? So for this I need to go to manage Jenkins. Again I'll go to manage plugins available. So I think it is already installed, so we don't have to install again. So let's go to manage Jenkins and configure system to configure the mail. But before that, let's wait till our MailHog's load balancer is provisioned. So here this is already provisioned for Spring Petclinic. So I'll just run the Petclinic project. See here, my Petclinic is also up, which means my Helm jet is also working. So let's list all the Helm releases from the cluster, and let's delete this test release which we just use. Just Helm delete, sorry, Helm uninstall test release, because we don't need this. And so I think MailHog is also ready. Let's go to the services. Okay, it is still provisioning. Yeah, mailbox MailHog is ready. So just copy this one, and so mailbox listens on 8025 on the UI. So this is the UI. You can see mailbox MailHog inbox is 0, there is nothing. And this is the IP address load balancer, and Mailhog SMTP listens on 1025. 8025 is the UI. So I need to configure email. So I'll go to manage Jenkins and then configure system. The first thing that we need to do is we need to fix this Jenkins URL. So this is pointing to some random value. So I'll use this one, HTTP without any slash, a proper Jenkins URL. Now let's come to the mail section here. So inside the mail email notification, I need to give the SMTP server. So what is SMTP server? So this IP address. So just give the IP address without any slash. I think you don't have to put HTTP also. In the advanced tab, use SMTP port as 1025, and that's it. Just click on test email, because authentication is not there, SSL is not there, TLS is not there. So I'm going to just give some email name, but this won't go to that email. So actually, if you click on this test connection, email is sent successfully, but it is automatically captured by your Mailhog only. So this is how you email configuration is done. So click on save, and now what you will do is you'll go to again this pipeline syntax generator, and here you can just search for mail, and here to I can give it to anything, like usually it will be the developer or someone who needs to get these notifications. So CC BC if you want. So subject I'll say test, body I'll say that test body, subject it is a test subject. Click on generate. So here it is generating this mail. Okay, if you see here it says BCC, blind carbon copy is nothing, body CC is nothing, from reply to all this. So this is the email template. So what I'm going to do now is at the end of all these stages. Okay, so this is the end of all these stages. So at the end of all these stages here, so I need to have the post build actions. So post build actions will only run after the each pipeline. So after the post command, so you can use either failure or you can use success, unstable. So all the post build actions are given in the Jenkins documentation, even in the repository at the end. Somewhere I gave the post build actions also. So you can refer this URL. So this will show you all the post build, like always, fixed, failure, success. So what I'm going to do now is inside our pipeline, in the failure, or else let's say in the success part, okay, I can just send the email, right? So here post, inside the success part, I'm just going to copy this whole thing here. So here I can also separate them at the commas. So this is also fine. So from address CC, if it is not there, just remove it. So reply to, okay, basically from is needed, so otherwise it won't identify. So from, I'm just saying it is Jenkins -notifications @gmail.com. So CC is not needed, and then reply to is also needed, not needed. Subject I'm saying it can be any subject. So basically in subject, in the body I can use environment variables. So if you see in the repository which I gave, so here I'm just saying, so body subject is Jenkins pipeline has failed for the job. So which job it has failed? So it is environment job name, because with the job name I can get the real time, so real environment value, that is what is the exact name of the job. And also I can just say the check log set build URL. So automatically at the build URL, so you'll have that link to the build URL, that is Jenkins build URL. So I can just copy this entire thing. It is the same thing actually. So this is the post build actions. I'm just copying it. So you can if you want, you can indent it with only 1 spaces or else 2 spaces. It is up to you. So since we are following only one space, one tab as a space, so I'll use this one. That's it. So you have the mail to from subject, so it will be dynamic. So job name will be replaced and build URL will be replaced. For failure, I'm saying it has failed. For success, I'm saying your Jenkins job is completed successfully. That's it. So this post build action will run once all the stages are done. So let's copy this, and then just go to your pipeline, click on configure, and click on save, and click on run. You can see end of the template, declarative post build actions. So mail has been sent. So if you see the mails, so here see Jenkins pipeline for Spring Petclinic is completed successfully. You can see the build logs at this one. If you click on this, so automatically it will take you to the build log. So build number 20 of the Spring Petclinic project is successful. So this is how you configure email notifications. So far we've seen how to write the complete end-to-end pipeline. So your complete end-to-end pipeline is almost ready with little changes to be done. But here we didn't do only one small thing, that is, so we did not run this particular pipeline only when the PR is opened or when the PR is closed. So we already have one particular video where we talked about generic webhook trigger. So I'll talk about this generic webhook trigger, how to configure this so that your pipeline will automatically start only when the PR is opened. So for this, what I need to do is I need to go to manage Jenkins, and then click on this manage plugins, click on available, and I can use generic webhook trigger. So this generic webhook trigger will send notifications, webhook notification to Jenkins whenever some event occurs in my GitHub. But this will also give me other post content parameters and all that. So I'll leave the link to this relevant video in the description below. So now my webhook is configured. So now I can go back to my repository, the pipeline, and configure it. So here I need to select this generic webhook trigger, and then you need to configure this URL, that is generic the Jenkins URL and generic webhook trigger /invoke in the Git repository. And also I need to add a token here. So token, I'm just saying test123. So here along with this particular URL, I also need to append this token in the form of $token is equal to token here. So what I'm going to do is I'm going to go to my Spring Petclinic, and I'm going to just go to the settings here, and then go to the webhooks. So delete any previous webhook. And here add a new webhook. So I need to add the payload URL. So payload URL. So as it is already shown, Jenkins URL by generic webhook trigger. So this is the generic. This is the Jenkins URL / and generic webhook trigger /invoke $token is equal to token something. So $token is equal to test123. That is the token which I just used. And here I wanted to use application by JSON. That is the format of data that is sent to the Jenkins, and I wanted to send only selected events. That is only pull request, and pushes should not be there. Click on add webhook. So now whenever I open a pull request, so what I can do is basically I can start this particular So last delivery was not successful, 404 error. I think it's a previous delivery or something. Okay, click on update save, and then here so here first, when we enable this, we give this test token, click on save. Okay, so now I wanted to test whether this webhook is triggering or not. So for this, I don't want to basically run any of the steps here. So even the first step also I'm going to make it as false, including the last step also, otherwise it will take a lot of time. So I'm just going to run this particular pipeline, but I'm not going to run any of the stages. Click on save. So here I don't want to basically run it manually through clicking on build now. So what I'll do is I'll go to my Spring Petclinic, and then here I'll start modifying this readme.md. I'll make any small change, but what I'll do is I'll create a new branch called something like prod, not prod, like say it's a feature, and I'm going to commit these changes to the feature branch. So once I commit the changes, and what I can do is I can go to pull request. Okay, so create a new pull request, and then open a pull request from the same repository from the feature branch, and here, so it is my own repository, so you need to select your own repository, and that too from feature branch to the main branch. So and then click on create pull request. So once pull request is open, so automatically you should see that your Jenkins pipeline should start. So you can see that the pipeline has started, but it won't do anything because we have disabled all the stages. So we'll enable it. So after carefully configuring it. So at least it is successful in getting triggered. So now what we'll do is we are going to just close this pull request by clicking on merge pull request and confirm merge. So let's see after merging also this is again getting triggered or not. If you see, again it is getting triggered, but my requirement is I only want this pipeline to start only when the PR is opened, not when again PR is closed. So for this, what I need to use is I need to use some parameters from the webhook. So if you see, so once my webhook is triggered, so if you go back to the settings, and if you click on the webhooks, if you click on the webhook here and recent deliveries, so here you can see your webhook data. So you have the payload over here. So this is a payload that is sent to the Jenkins. So now from the payload I can see what is the action, whether PR is opened or not, and you can see the recent delivery, whether PR is closed or not. So which means I can read these values and decide when to run this pipeline, so whether when PR is opened or when the PR is closed. So for explaining, so what I'll do is I'll take this complete JSON payload, and then let's see what are the various values that we can actually read. So first thing is I wanted to read the action value, whether it is opened or closed, and from where, and that the requirement for me is I wanted to just run the pipeline only when the PR is opened, that too from the feature branch to the main branch, that is target branch should always be main branch, and the first branch it should be always feature branch, so depending upon the requirement. So how do I find it? So inside the pull request, so you can see there is one more section called head. So if you see the head and reference, it will give you the name of the branch from where PR is open, and also the another one which is this is the head. Somewhere you'll also have the base. So base ref will give you the target branch into which branch your pull request is open. Like So it is now opened into the main branch from the feature branch. So that is the meaning of it. And the action indicates the open. So from the webhook data, what I can do is I can go to this pipeline, configure pipeline. So I'll read all these parameters. So these are all called post content parameters, because your GitHub is sending some JSON payload, and then from that payload I'm extracting the information in Jenkins. So I'll try to add. So the variable is action. So from where I can read that particular data. So if you see, I can read from the action, but how do I read it? So it is actually $.action, and I'm storing its value in the action. So if you don't know how to do this, so first you need to check this option here. So if you click on if you go to generic Webhook Trigger Jenkins plugin, so inside this plugin description, so there they are giving all these information. So here, so if you so I think it is not given here. If you see this one, generic Webhook Trigger, you can click on this Git Repository or filter with variables. You can see here, so whenever you receive information like this, and if I need the ref, so it is $.ref. So it will give somewhere, so maybe JSON path here, syntax here, not this, yeah, here. See here, so if you have the some JSON object, so what is this JSON object? This one. So here we have a store and some dictionary. So in order to access this store, what you need to do, you need to start from $, that is the root element, and then you need to use .store, and after that .book. So you need to go into the other levels by using dot operator. So this $.action will give me the action. So now if I wanted to see the head value, that is head ref. So this head and ref is under the pull request. That's it. So here I'll go back to the generic Webhook Trigger, and then here one variable I'm accessing, it is $.action. I'm calling it as action. Okay, another value I'm going to add. So this value, it is $.pull request underscore base, sorry, it is head.ref. So this is the reference for the head. So pull underscore request head.ref. So this one I am calling it as head. So this is the pull request is opened from here. So this will indicate the branch. So select the JSON path. So it is automatically selected, but it is not showing here. Again, add one more. So this time it is called $.pull underscore request, and then .base.def. So this is the target branch. So this one I'm calling it as base. So now I'm here. So action indicates what is the action, that is open, closed. Head indicates the source branch. Base indicates the destination branch. And now, since I already have these three values, so now I can create a filter. So here the filter and expression, if they match, then only this pipeline will start. So what I'm saying is, if $action, because this action will have the actual open or close data, and this head and this base, if these three values, if it is equal to open from feature branch space, what is the destination main, so these three values will automatically, they will resolve. If they match this exact value, this means this filter is successful, matched. So let's say I wanted to run this pipeline for all the PR opened events, and the base branch is only main. That means you just remove this. So which means if action matches the open, base branch matches the main, then automatically this pipeline will trigger. So let's click on save. So this time, see here, my pipeline is not started yet. So what I'm going to do is I'm going to go back to my repository. So there is a pull request. Okay, so what I'm going to do is so we already merged, so let me go back to the repository and then change it to this feature branch. Change this, add some information or something. So I just remove this dot and click on commit, and here go to the pull request, open a new pull request. So from my not main, from my feature branch, I'm going to go to merge it back to the main branch. So it is from it's from my feature branch to the main branch. So create a pull request. So now automatically your pipeline should start. So only for the pull events, that is PR opened events, basically your the pipeline will start. So if you see, the pipeline is successful when the PR is opened. And let's try to close the PR. Now let's try to close the PR. Click on merge. So which means the PR is closed. So when the PR is closed, if you see the Petclinic project, so here your 24th number build should not start at all. So if it start, again our logic is different. So what we said is only when PR is open, that is from feature branch to the main branch, then only your this thing should work. Otherwise it should not work. See here, it is not started still. So now let's talk about the final thing. So which is, so whenever you open a PR, so let's say you opened a PR, so but here when you open PR, so you don't have any information about the Jenkins pipeline. So let me show you one quick example. So I'll go to the Spring Petclinic project. So I'll switch to this dev branch, and then what I'm going to do is I'm going to make a small, so not dev, let's go to the feature branch. Let's make a small change. So here I'm going to add an extra dot or something just for a small change, and let's click on commit changes. So now let me open a PR. So PR open from, so my repository from your feature branch to main branch. So let's click on pull request. So here once you click on pull request, so automatically your branches will be checked, and your Git is only showing whether there are conflicts or not. But when a PR is open, actually in the background, so a pipeline is getting triggered. So how do I get the information whether this pipeline is successful or not directly onto the pull request? So what if I can just get that information here, so that when pipeline is successful, I will directly go ahead and merge. If the pipeline is failed, I'll just close it. So I'll ask my developers to fix the changes, fix the bugs again. So how do I get that? See, basically I can only get that information only when I see the pipeline here. So what if I can send the information back to the GitHub? So for this, GitHub has a particular method, so which is called updating a commit with a message. So here in the repository, so which we have, so here I gave a logic here, so that is sending status to GitHub. So here sending status to GitHub means so basically you can send some information about your pipeline to GitHub. So it is like updating a commit status. So if you go back to your repository, so here this Spring Petclinic project, so in the feature branch I made a commit. So this commit hash is this d43. So in this commit I made a small change in the pom.xml or readme.md file, some changes. So now I opened a PR from that branch to the main branch. So here if I can update the commit with some message, that message will come here. So how do I do that is GitHub has certain APIs to do that. So those APIs and all I've already given in the repository which I just shared. So it is here. So if you go to this link which is create a commit status, so on the right hand side you can see what is that request that your GitHub is expecting. So it is a curl request and it is accepting this one. You need to give your username and password or the bearer token, and then you need to send the status. So let's say I'll just copy it. So here it is accepting a post request, and this is the header, this is the authorization information, and then this is the API call which will just update the repository status with the latest commit hash which is SHA with this information. So this -d indicates a data to transfer to a commit SHA. So here state success or failure it will take, and then the target URL, anything, description, and the context here. So context also, some context you can put. So here what it will do is it will just display the status and some description also. So I've already given in the I've already shown in the screenshot before. See here I'm showing some information here, and also whether it is successful or failure will be indicated with this particular marks. So I need to use this particular curl command, and then I can just update whether it is passed or failed a particular step. So for this I already created an API call in the repository. So with credentials, so I can use the GitHub credentials. Okay, so let me copy this. It is same thing. So with credential block will provide the credentials to the variables. So here curl user details, instead of bearer token I'm using the username and some password. Okay, so not this, so this one, sorry. Okay, so curl, so username and then my token, and then post request. So you can see the API call. So this is the HTTPS API github.com. This is a repository, this is a Spring Petclinic repository statuses and SHA ID. So I need to find the SHA ID, commit SHA. So I'll show you how to find. And here as the data, what I'm saying, the state is success. Context means what is successful. So just a small name. So I'm saying Maven build is successful, or Git checkout is successful, or Sonar scanning is successful. So either successful or failure. And the target URL, so basically for this particular success or fail, I'm just giving the URL to my console. So to my job name, so to that particular build number, I can give the console URL, so that whenever someone clicks on this URL, directly they will be given, they'll see the console of my build job. So this is what I wanted to use. And here first I need to create a token for the user. So what I'll do is I'll go back to my repository. I'll go to the repository settings, and then click on the developer settings, and then personal access tokens. So generate a new token, so call it as test, and then give this repo access. Click on generate token. So test is already there. Let's do test2 and generate. So this is the token. I wanted to store it in the Jenkins credential system. So go back to your dashboard, manage Jenkins, and go to the manage credentials, Jenkins global credentials, add credentials of type secret text. So this is a secret. The ID I'm just going to take it as git token, and then the description is also git underscore token. So this is the token value. So this token can now we can access it in the form of variable. So for this what I can do is I can go to pipeline syntax generator again. I'll go to with credential block again, and then I wanted to use the secret text, and it will automatically ask me which secret text. I'll just use it as token, so that secret text is available for me in the form of this token variable. So git token, so generate, so automatically it will generate this logic. So this is the same logic. So basically I've used here, so with credentials git token variable, so I'm using the same name so that it will be easy to follow. And the repository names and everything are already found, but the SHA ID is not there. So how do I find the SHA ID? So basically so if you see the webhook data that is sent inside this pull request, somewhere you'll have the SHA ID or commit SHA. So if I just search for commit, so this is the commit, or let's say SHA maybe. Yeah, so this is the SHA. So from where you can get from head, because head is the base branch. Okay, so from here only you're creating a PR. So in head branch only you'll have the SHA. So head SHA, and basically in the pull request, so pull request head and SHA. So what I'll do is, again I'll go back to my pipeline, click on configure. So in the post parameters, so I'll add one more parameters like this one. So add, so I'll say SHA underscore ID, some identification. So this one, it is from again $pull underscore request dot head dot I think it's SHA. So it is SHA, right? Yes, it is SHA. JSON path you select, click on save. So now what is the advantage of using that particular function which we just seen is, so I can use this function to send the build status information back to the GitHub. But instead of calling this for every step, what I did is I created a function. So what I did, I created a function called send status, and then I'm running it inside the curl container. So I'm using with credential block to bind the GitHub token to a variable, and this whole curl request which we had just seen I've given here. But the thing here is every stage name is different, and we'll know whether the stage is a stage can be a pass or a fail. So here in the curl command, so here in the data that we are sending, so I need to send whether it is success or failure, and also the context, which stage name basically. So all those these two details like status and then context, so I'm calling it as a stage name and a status, and then this stage is a variable, status is a variable. So I'm replacing them in the actual data. So if the state is $status, context is $stage. So whenever I call this function, so basically I'll call it with this particular name, and then I'll give the name of the stage and whether it is pass or failure. So it will obviously call this function, and no need to repeat this function every time because I'll just call it. So it is like reusing a piece of code. So I'll use this function. So what I'll do is at the end, so I'll put this function at the end of the pipeline. So this is how I so this post build action should be indented a bit so it looks good. Okay, so I have a function called send status. So now it is taking the stage name and the status, then it is updating the stage and the status information back to the GitHub repository. So this is the repository name. Okay, so and this is the SHA ID which we just calculated. So now what from where I can call the send status, so I can call it from anywhere. So now let's try to build it from scratch. So everything is done. So now we have the git checkout, so I'm enabling it, so true, and after these steps, okay, so I can have post build actions here. Okay, so post build, when it is success, what I will do, so I'll call this function. Okay, so how will I call this function? So I already gave, so send status and the name of the stage and basically the success or fail value. Okay, so I'm saying this is git checkout, this is the stage name, and status, if it since it is success, it is marked success. So you can also have one more. So if it is failure, so you can say the same message, but instead of success you can send it to fail. So that is fine. So you can also do that. So I'm going to repeat this post build block for all these. Okay, so here this software build, Okay, so this is also needed, so I'm making it as true. And then I'll copy the send status, because there is also a possible block here after JUnit. So I'm saying this as a software build, it is success. And now here this one for the Sonarscan, so I'm going to enable this also. And for this also I'm going to put the post block. So after the steps, so I can give post build. So this is the Sonarscan, so whether this is pass or failed, and then wait for quality case. This one also I need to enable. So for this also I'll just say post build action, QZ check, some name, and publish artifacts. This is also needed. Okay, and so after the, what is this one? This is the steps, right? So this one after the steps, so this one I'm saying push to Nexus. Okay, it is success. And there is a small typo here. So publish artifacts to curl commits not needed, build Docker images, it is needed. And then after the all steps I'm going to give a post build action. So it is say push to DockerHub, success. Deploy to Kubernetes via manifest not needed, through Helm I need. So I'm going to put it as true. And again I'll say this one as deployment, it is success. So there are two ways, right? So one Helm chart we uploaded it to the repository, one we doing it through Nexus. So let's enable this, let's disable this. So anything is fine because you already checked in. So here also I can just put the post build actions for all these steps. Now here deployment is success. In post parameters, so finally what we are doing, so we are sending the email notifications, but for every stage we are just updating the GitHub so that it knows whether the complete pipeline is successful or not. So let's take this whole thing and then go to our Spring Petclinic project, click on configure pipeline and then save. Okay, so now it will trigger whenever we open a PR. So let's go back to the Spring Petclinic project, go to the pull request. So let's delete anything if we already have. So I'm just going to mark as closed, it's not needed. Now let's go back to the repository, click on this feature branch. Let's make some changes to the pom.xml file. So in pom.xml file we are going to change the artifact version to something like 6.66 and then commit to the feature branch, go to the pull request, open a new pull request, and here I'm opening the pull request from my own feature branch to the main branch. Now click on create pull request, now see the whole magic here. So once it is open, so basically your pipeline will start. So for every stage, so we are sending the feedback. So the first, let's see all containers are starting or not. The first step is git clone. So git clone is successful. Now you can see one check is successful. You can see all checks. Git checkout is success. So similarly after each stage, so it should give you all these. So let's wait. Now you can see that all stages are successful, and there is one issue here, Helm repo add installation failed, cannot reuse the name, that is still in use. So here we have used Helm install, so it should have been Helm upgrade. So because that particular release is already available, so instead of using Helm install, you can use Helm upgrade -- install. So this should have solved our issue. So let's copy this and run. And the reason why the failures are not being shown here, because we only put the success, we don't have the failure parts. So let's copy and rerun the pipeline. So in order to just start it only when PR is opened again, so what I can do is I can just close this PR and then I can immediately reopen it. So this will again re-trigger my pipeline. So now if you see we are able to install the Helm chart also, and so here all checks are passed, and coming to the Mailhog, so basically we closed it, so we can open the Mailhog also. Let's see whether we got the email notification or not. So 8025 is the UI. You can see that the pipeline is completed successfully, and let's go to the Nexus and see whether so this is the SonarQube. So SonarQube again, anyways it will pass. And if you go to the Nexus and if you try to browse the contents of your Maven hosted, you should have that latest 7.77 which we just created, which we just tried to push. So that's it. So we have almost covered all the tools. So let's try to recap what we have done. So first we created we have taken Spring Petclinic project, and then we tried to build, run the test cases, and also run the Sonar analysis. Now once Sonarscan did those analysis, we sent it back to the server. So server sent it its quality gate information through webhooks. So Jenkins, depending upon the webhook information, so it failed or it passed the pipeline. That means if it is failed, it will abort the pipeline. If it is passed, it will go to the next step. So in the next step, we had seen how to push our war file to the Sonar type Nexus in two ways. One is using the Nexus plugin, and other one is using the curl command. In the next step, we dockerized it and we sent it to DockerHub. And after this, we went to the deployment through Helm charts. So we also configured the email notification. So once everything is done, so you will get the email notifications. And also we try to send the notifications to GitHub pull requests also. So in the pull request, you will see whether all the stages are successful or whether there are some issues with the stages. And we also try to connect GitHub with Jenkins through webhooks, and that too only when PR is opened from the feature branch to the main branch, we try to trigger the pipeline. So maybe this pipeline is for some it may be very easy because we have used only the basic steps. For some it may be very difficult to understand, but once you practice everything, you will understand it easily. In all these stages, we only consider about the success. So if you wanted to also write the failure test case, so you can also use this failure block. So you can also do this, and also you can also simplify this, so you don't have to use so many stages. So you can also even separate the deployment part and make it as a manual one. So that's it for this video. So I'll see you in the next one. Thank you so much.
You